workshop of the SLIoT Challenge 2023.
SLIoT Challenge is the annual IoT competition organized by the Department of Computer Science and Engineering of the University of Muruduru in collaboration with SLT Mobitel and the Institution of Engineers, Sri Lanka. Today's session will give you valuable insights on intellectual property, patents, business development, and many more interesting fields. We also have a Q&A panel discussion lined up for you.
To officially commence today's events, I would like to invite Ms. Vayani Saranga, Product Development and Management Engineer at SLT Mobitel, to deliver the welcome address.
Good morning, ladies and gentlemen. It is my honor to warmly welcome each and every one of you on behalf of SLT Mobitel. Dear lecturers from University of Muruduru, the esteemed guest speakers, dear participants of SLIoT Challenge and the marvelous organizing committee, I dearly welcome all of you to the SLIoT Challenge University and Open Category Workshop. SLIoT Challenge is not just a competition. It is a celebration of ideas, collaborations, and innovation. As we look around, we see a diverse group of individuals, each armed with their unique perspectives and skill sets. Whether you are a seasoned professional, a student, or an avid IoT enthusiast, this is your stage to shine. Today is all about active engagement, learning, and the exchange of ideas. The world of IoT is dynamic and ever evolving, presenting us with endless possibilities to shape our future. As we embark on this workshop, I encourage each and every one of you to seize this opportunity to the fullest. Thank you for being here, and let's make the most of this incredible opportunity. Welcome to a journey of explorations, discovery, and innovation in the world of IoT. Thank you.
Thank you, Ms. Vayani.
Speaking of SLT Mobitel, the Embryo Innovation Center proudly presents the IIoT Development Kit, which is a development board such as Arduino and Node MCU equipped with built-in NB IoT WAN technology. Further, it has Wi-Fi and Bluetooth connectivity for IoT development.
This kit is designed to elevate the productivity and quality of IoT applications, offering NB-IoT capabilities, simplicity, cost-effectiveness, and quick and easy installation capability. It comes with a library of comprehensive user manual, which you can easily refer online. You can also experience seamless development with our IIoT Development Kit, which is an innovation of SLT Mobitel Innovation Center. Let's have a look.
That is almost all of the developments. Projects require internet connectivity. Development boards help system designers to develop and test projects easily and speedily. NB-IoT, Narrowband Internet of Things, is a low-power technology that is designed for Internet of Things, IoT, applications, and other low data rate communication requirements. To set up NB-IoT communication, people face challenges such as requiring additional knowledge, scarcity of components, high module prices, extended development time, and limited penetration due to inadequate support from telecommunication companies. SLT Mobitel, the Embryo Innovation Center, introducing IIoT Development Kit. This is an entry-level development board with inbuilt NB-IoT, Wi-Fi, and Bluetooth connectivity to enhance the productivity and quality of IoT applications. In addition to that, the Development Kit library provides simplified functions to utilize NB-IoT connectivity with all the NB-IoT features. IIoT Development Kit is designed for various applications such as IoT devices, smart water and electricity meters, sensor data collection, and aquaculture monitoring systems. This kit is your key to revolutionizing industries. Get ready to embark on a captivating journey of innovation.
Alright, without further ado, let's begin with the first session of today's workshop. For this session, we have the pleasure of introducing Professor Chatura De Silva from the University of Moratuwa, Department of Computer Science and Engineering. Sir, the stage is all yours.
Good morning to everyone. So, in this session, what I'm going to talk about is how a thing, like Internet of Things, we are talking about things that are connected to the Internet. So, how a thing is organized, what are the, and when you develop something on IoT, when you develop the object or thing, what you need to look at and how you can sort of separate the workflows. I mean, what you need to can do on the device itself, what can be done on the servers, etc., and what are the things that you need to consider when we do it. I'm not going to go into deep technical aspects of that. I try to cover it at a very high level due to the time constraint and also the diversity of the audience that we are having. So now, as the name implies, it's a network of objects. Right? I'm not a network of various different type of objects. I mean, if you look at the historic Internet came as a network of developed at a very rapid rate, and now we have actually more devices than computers connected to Internet. So that's what the term Internet of Things or IoT came in. Now, when you get a thing, I mean, what thing is object? It could be something that you are wearing, it could be something that you are using, it should be something like a car or a large machine or even a small wristwatch or something, an implant that might even go inside you, right, a medical implant. So when you look at the anatomy of that, I mean, how it is done, what are the parts inside that, right, how it is made, there are two different main aspects, primary aspects that you need to look at. One is the physical device itself, how it is made, what are the components that you use, and how those components are organized. Then what operations that it is expected to support. I mean, there are certain functional operations that the device is expected to support. For example, if you take a wristwatch, the main functional operation may be showing the time correctly, right? And there may be other supplementary functional operations like having the calendar, giving an alarm, things like that. And then there are also other hidden functional operations, or what sometimes called non-functional operations, like maintaining its own resources. For example, how it would conserve its battery power, because we have a very small battery in a watch, but that need to be running, delivering power. So how you optimize that power usage so that with a per charge it can run for long period, right? And also how you make sure that the battery power is managed properly, so the battery itself will last long, because every battery has a lifetime. When the lifetime is over, you have to replace the battery. So how that you can elongate that lifetime as well. So that likewise, when you look at operations, there are different type of operations that are involved. So typically, in terms of the sensor, we have the device itself. We have sensors connected. The sensors measure the physical world, right? It could be temperature, it could be humidity, it could be a GPS location. It measures those environment things and convert them into some sort of a electrical signal that the device can process. Then you have actuators. Now actuators do the reverse of the sensor. It gets some command and then act on that. So the display is kind of actuator, right? It might have a vibrator, right, vibrating alarm. So that's an actuator, likewise. Then there are interfaces. Now these physical devices need to be interconnected in between, inside. So there are interfaces which will make sure that the voltages, currents, and all those things are matched between the two devices. Then it need to do some computing. Computing means that it need to do certain calculations, it need to take certain decisions, etc. So it needs to run a software doing some computing functions. Then there's local communication. The components inside the device may need to communicate with each other, as well as the device may need to communicate with other devices in the local vicinity. We call machine-to-machine communication or M2M communication. And there's another aspect for remote communication. It might also talk to a server in the cloud, right? Now your phone communicates with the Google Cloud. Two servers in the Google Cloud to get certain, let's say the map information, various things, emails, etc. So it can be remote communication. That's power management, right? How you optimize and conserve power available in the device. So likewise, there are different device-specific aspects that you need to look into. And in terms of operations, what this kind of activities this device should support when you develop a device. One is, most devices should be self-configurable. Now when you buy as a consumer, because you are producing something for end users who are not IT specialists, right? There may be people who simply want to get it out of the box and start using it, right? So you can't expect to get it out of the box, download some software, configure, or do anything like that. It should be ready to run from out of the box condition. So, but to run that, it need to configure. For example, this wristwatch, right, which is IoT device, may need to communicate with your phone as well as may need to communicate with your home Wi-Fi. Now, communicating with phones, you might want to do some Bluetooth, various small setup. But communicating with Wi-Fi, then you have to put the password, various other things, and configure it. And some users, in fact, most of the end users that will buy your product may not have the technical capacity to do that. They might know how to pair a Bluetooth device, because that's very simple. You scan the device and simply do the passcode and it get connected. But connecting to Wi-Fi, you have to select the Wi-Fi, you have to do whether the signal is okay, and then you have to give the password, SSID, and all those things. Right? It is difficult. But how these things operate? Now once you connect to your mobile phone, it automatically configures the Wi-Fi based on information in the mobile phone. Right? So that's self-configuring. Right? So the things that you need to do technically to start using the device need to be minimized. And then it may have to work with unreliable communication, because Bluetooth, you pair it and you are wearing the watch, but you may not have always the phone on your pocket. So you might go somewhere, it get disconnected because it goes out of range. And when you come back, you can't ask it to pair it again and go through all that process. It has to automatically connect. Same with the Wi-Fi devices. So it has to work with the environment where the communication is not reliable. Now if you take a computer, that is not the case, because you have the computer always connected, you can see the Wi-Fi connection and all those things. So that works in a bit of a more reliable communication environment. But here it has to work in an unreliable environment. And then it has very limited resources. I'll show that later. So technical resources in the device will be very limited. And it has to fail safe operation. Any device, irrespective of how good the components, how good the quality is, can fail. Right? But the more important thing is that if the device fails, what happens after that? it will be safe for the users. Take a lift, elevator. Now, elevator can fail. I mean, it may not get power. I mean, power disruptions can happen. So, it should be designed such a way that when that happens, it should not fall down, right? At least it should stop, so that it is failed. It has broken, but that will not cause harm to any of the users. So, it has to be designed in a way that it always fails with a safe state. And so that's a very critical factor that you need to look at when you are doing, end user devices. Yeah, the consumers will be using that. And it has to work in a harsh environment because it may be subject to heat, water, various things, right? And it has to conserve power. It should be designed to work with minimum amount of power requirements, so that with a pair of one charge of a battery or one pair of, let's say, double size batteries or whatever, it works for a long period of time. And it may have to provide real-time response, right? I mean, when you give an input, when something happens, you can't wait until couple of minutes or couple of hours to get the response. It has to work in a guaranteed response time. When you press a button, the response should come within a guaranteed period of time, right? So it may not be instantaneous, but it should be, let's say, within 1 second, within 2 seconds, some guaranteed period of time. Now these operations, this is from a logical view. I mean, this is what you need to think of when you design a IoT device. But implementing that, you have to decide what type of these operations, what parts of these operations will be implemented on the thing, on the device, or what will be on the internet. So to understand, we need to look at the pipeline, how they are connected. Now at the remote end, right, users end, we have the sensors and actuators. That's what you see. You see the screen, you see press a button. So that's the end of one end of that. And then they are connected to a microcontroller, basically a small computer. Microcontroller is a small computer in a single chip, right? So to connect that, you need interfaces, hardware interfaces, because the voltage, currents, various protocols used by these actuators may not be compatible with the microcontroller. So you need to have interfaces to match those things, right? And then the microcontroller will also have some software running inside there, which provides most of the functional aspects of the device. Then so that is what is on the thing. So what you need to consider, so the processing that typically happens on the device, we call the edge processing, because that at the processing or the data manipulation that you do is happening at the end of the pipeline, closer to the user, right? We call it edge processing. And sometimes it's also called the embedded processing, etc. Right? This is something called the fog layer. I'll come to that later. And when you design that, we need to be mindful of these things, that we have very low amount of computing power, right? I mean, you're not having a supercomputer in this your wristwatch. You have a very limited amount of computing power. You might be able to add 2 numbers, but not even to multiply 2 numbers. So your program has to be simple as possible, so that it will not overload. Because more complex programming is more computing power, means it also needs more battery power to run that one as well, right? So you have to optimize your algorithms a lot. So it will run on low energy, and also the device itself may be less reliable. Suddenly the battery might go flat, right? So if battery goes flat, what happens to the operations that you have been carrying out, right? So that you need to look at. And you are producing, if you are coming up with a product, and if you are making it a commercial product, you will be producing this with very large quantities, right? And that's a very critical aspect you need to look at. Now when you design with certain parts and components. But you have to think whether I'll be producing, let's say take a wristwatch, I select certain parts, I select a processor, I select a temperature sensor, I select a screen, etc. from various manufacturers. But if I'm going to produce this, I mean, if I'm going to sell it, you may produce about 1 million units of this, right? So for this 1 million units, the parts that I am selecting, are they available? Because sometimes what we see is that you come up with the idea, you build something at a very low cost. Why it is low cost? Because you salvage some parts from some old toys or some other things, right? Now that is good for the concept. But when you go for real production, you are not going to get those millions of old broken toys to get those parts, right? You have to go with new parts. So you have to be, even though for your prototype you select some old components, you need to check whether are those components available in the market now. Will they be available in next 5 years time, right? Because you need to provide spare parts, support, repairs, etc. and whether those will be cheap, or I mean cost effective, right? I mean your toy might have it, toy might be broken, so it doesn't have the residual value, but if you buy it new, it will be very expensive. So you need to think of that as well, right? Because once you have done the design, you have tested and everything, changing that will be another cost in terms of time and money for you, right? So then what will generally go on the internet, right? Now, so the communication will happen between these two, and then you will be connected to some service provider. It would be Amazon, it could be Google, Azure, Huawei Cloud, or whatever, some sort of a cloud service provider to manipulate this data at a more deeper level, right? It will do two things. One of the heavy computing that you need to do can be done on the cloud, so that you have enough computing power to do that, or else your device may be, your system may be such that it doesn't depend on one person's data, but it depends on many people's data. Now, for example, the way that Google will predict traffic is by collecting data from not only one person, but from hundreds of or thousands of people who are in that particular area. Because when you collect them, you can easily eliminate outliers and you get a more statistically reliable estimate, right? So those things will usually go in cloud, right? So typically if you are using vision, computer vision, if you are processing images, that might be option to do it in the cloud rather than on the device, because vision processing requires a lot of computing power, memory, and also energy to do that. Voice recognition also something like that. Now, for example, if you want to do voice recognition, you may not want to write your own voice recognition algorithm. You might use something like Google Assist service or Amazon Alexa service, which is available in the cloud, where you send your voice clip, it decodes that and send you the text out of that, recognize that and send the text out of that. So that processing you might want to subscribe to what is already available. Same thing for natural language processor, data analytics, machine learning, etc. Right? So one thing that you need to look at is to divide these two. Because some of these things you might think, okay, I can do on the device also. For example, if you get ESP32 chip, you can do some computer vision there. You can do even some voice recognition there, even on a little bit of a high memory Arduino device or a Raspberry Pi, right? But whether doing it here, the other requirements of that, power requirements and other things, will that be sufficient? Whether I can support that in a physical device, or whether should I do it in the cloud. So that's a decision that you have to take when you plan this device. So let's take an example and see. Right? So this is a watch, right? I mean, I took the example of a Samsung watch to see it. So the concerns that you have to look at is the battery capacity. Now it has a very small battery, 350 milliampere hours, right? So 350 milliampere hours is a very small battery capacity, right? I mean, if you take a AA pen torch battery, that has more than that, right? So it's a very small battery capacity. It has a mic and a speaker, right? It has Bluetooth connectivity, it has Wi-Fi connectivity, and it has a color display. It has a temperature and humidity sensor. It has a GPS sensor, right? And it has a oxygen saturation center, that's SPO2 center, which can measure the blood oxygen. How it does it? That it fires a light and see how much of light is reflected, and depending on the oxygen level, the color of the blood in a particular wavelength will change. So it detects that and see whether how much of oxygen is in the blood, right? So that's SPO2 sensor. And it also has a heart rate sensor. And most of the devices now actually don't use the heart rate sensor separately, but it measures it through the blood oxygen sensor, because when the heart pumps, you get more fresh blood with more oxygen, and after that, when the dialytic state, the color changes. So based on that color change, from the same sensor input, it can determine the heart rate as well, right? And then for communication, it can be connected to the phone through Bluetooth, as well as it can be connected to Wi-Fi directly. So what it will do is that it will first use phone as the primary option, because Bluetooth uses less power compared to Wi-Fi, right? Because it's designed for short range communication. So it will use Bluetooth as the first option, and if the phone is not nearby, if the Bluetooth is not there, it will automatically switch to Wi-Fi, and you don't need to configure. It's self-configuration of Wi-Fi, because it will get the Wi-Fi connection details from your phone itself. So whatever the Wi-Fi network the phone is connected, when the phone is not there, that watch will directly connect there. So that's how it is designed. Right? I mean, the manufacturers could have thought, okay, I mean, to make it more reliable, since Wi-Fi is more widely available, I would connect it directly to Wi-Fi without Bluetooth even. Right? Because you can also connect to Wi-Fi, and from Wi-Fi you can connect to the phone as well. That's theoretically possible. But they have not done that because doing that will use more battery capacity. Right? Because Wi-Fi needs more energy, and you have to always check whether the phone is nearby and so on. So those are the things that you need to consider. Right? You have to think about when you do design. And then it connects to the internet. So in this case particularly it connects to Samsung Cloud, and also it can work with Amazon Web Services, Microsoft, as well as the Google Cloud. I mean, depending on the account that you are having, and even to configure the Google account, right? I mean, you don't need to go here and enter your password. What it does is that it uses your Google account information in the phone. It replicates that automatically as a trusted service and then connect it. And so that's how it becomes self-configurable also. Now, all of these are possible because of a computer running inside there. But this computer inside this, the embedded computer, is different from a traditional computer like this. Why? It has been designed for a specific type of and specific purpose of work, compared to this kind of a larger computer which is designed for more general work. Right? So let's look at some of those things, because those constraints also matters what you can determining what you can do with your device. Now here, if you take a traditional computer, I mean maybe a PC or a laptop or notebook, whatever, so they are designed for large data intensive computing. They can hold large volume of data because they have a large memory and storage, and they have powerful, very general purpose, I mean processors which has a very large instruction set, which can do various type of processing, adding numbers, subtracting, multiplying. And when you say adding, multiplying, it can be integer numbers or it can be floating point, fractional numbers, because fractional number multiplication is more computing resources than integer numbers, right? And it has fast network connections. It compromises power to having fast network connections, and large screens and keyboards where users can provide their input. But they have very limited input-output capabilities. If you take a normal modern laptop, you get about 2 USB ports, which has to be used for everything now. Right? I mean, earlier computers had serial ports and parallel ports. Now they are disappearing. So it has very limited input-output capabilities, and the power is not an issue. You can have a large battery. You can always see it can be connected to power outlet, etc. But if you take a thing, IoT, right? Now they are designed for interaction with the environment. They are not expected to hold large volumes of data, but they are more intended to interact with its surrounding environment, right? And they have very limited storage and memory, and they have very specialized processors which are optimized, scaled down, fit exactly into what you need, right? So the difference is like this: the selection of the processor. Here, what you need to do, what you can do with the device is fairly independent of the processor. You can run a game, you can run a large data spreadsheet, you can browse internet. All those things is possible with this processor because the processor is general purpose processor, like a three-wheeler. You can use it for various things, right? But here, it's like a motorcycle or something which is designed for a specific purpose. So if you are going to use it outside that specific purpose, it will be very difficult. So even selecting the processor itself. Now for example, if you are building something, if you need Wi-Fi connectivity or Bluetooth connectivity, you have an option of getting an Arduino board, right? And then adding a Wi-Fi adapter to that one. That's one option. Or you have the option of getting a ESP32 board, right? Or Node MCU board, which has Wi-Fi built into the processor core itself. Right? Now, because then you have to also look at the power requirement. The Arduino board requires very little amount of power, but ESP board, it also runs on very low power, but more than Arduino board. Right? So depending on now, if you are not using Wi-Fi, using the Arduino board may be much better option because it can help you to conserve power. But if you need Wi-Fi, having the Arduino board and having a separate Wi-Fi adapter might increase the board size, the size of the device, and also increase more power to that. So in that case, using ESP chip might be better. Then also the cost, because if you are using the Arduino chip, not the board, the chip itself, it is very cheap. ESP chip is a bit more expensive. That also you have to look at. And also the IO things has diverse IoT input-output capabilities. You need to work with analog devices. You need to have multiple interfaces connected to that one, right? You have to use with the character mode data transmission, that you have data where you send one at a time, one element at a time, or you have to deal with large blocks of data like images, etc. And you have to have high energy, sometimes control high energy devices, because you are not a watch, but your gadget may be controlling a very powerful motor like in air conditioning, right? So you have to deal with this diverse range of devices or IO capabilities, input output capabilities that might be connected. And also IoT things often has a battery, which has a very limited energy capacity, as I mentioned. So that's again another thing that you have to look at. So let's do a comparison between these two. Right? Now, if you compare watch with the computer, right? Now watch will have a 320 milliampere hour battery, whereas the computer will have a 6 ampere hour battery, almost 20 times more. Screen, right? It will be very small, very low resolution, 240 pixels by 160 pixels, whereas this will be a full high definition 1920 by 1024 pixel display. So you can display a lot of information there, but in a watch it's only a very small amount. Storage, this will have about 64 GB maximum with all flash and everything. Here we are talking about in terabytes range, right? So likewise you will see that many differences. The physical weight of the device, this can go up to 1 or 2 kilograms, maybe up to about 2 kilograms is acceptable, but here the watch has to be couple of 100 grams, even 150 grams may be too expensive, too heavy for certain applications, right? So all these constraints because of that, designing an IoT device is challenging. It's easy to design a prototype using Arduino board or ESP chip, but when you go for a real product, right, real enclosure, real product, all these extra things come in. So it's difficult to change them later. So you have to think about that at the beginning when you design it. Am I using the best processor available for this? When you say best, it's not only because of the computing power or the features, best in terms of the price, best in terms of the power consumption, best in terms of the physical size, the weight, and all those parameters you need to look at. And you have to make a decision based on that, compromise based on that. So if you look at those requirements, some of those things, now I'll not go into details of general computer architecture because that's all obvious, but let me look at what will be the requirements for IoT thing, right? So it requires limited processing power to handle input and output, so you should not select extra one. Now for example, if you need a little bit more flash memory, so let's say your application requires flash storage of data, maybe small volume. Now if you detect Arduino board, there's no flash storage available, so you have to have an extra flash adapter, SD card adapter and so on. But if you use a ESP chip, again there's inbuilt flash memory. But on the other hand, you have to think about how many times you are going to write to this flash memory, because flash memory is a consumable type of memory. I mean, you keep on writing, that's called write-where. The flash memory becomes less and less reliable when you keep on overwriting it, right? So your pen drive is not something like the hard disk which you can erase and write for many number of times. You can do it for a couple of thousand or 100,000 times, but there's a limit, right? So if you are using the ESP chip, the data can be written about 20,000 times. 20,000 times, right? It's a large number, but if you are writing it every 1 second, then you have to think about that, right? So all those parameters you need to think, and it requires only small amount and fast memory. Typical IoT device handles only few IoT, but selected from a large diversified IoT input-output requirements. It includes analog, digital devices, and you should look at saving energy as much as possible while providing the reliability of operations, and always select the platform or the design which requires the least amount of external components, because each component that you add to your board is a cost. It is a cost in terms of financial, because that component will cost you in production, It's a cost in space, it's a cost in weight, it's a cost in power consumption, it's a cost in reliability, because every soldering joint is a potential failure point, right? So the less the number of components that you can have will be always give you a better, more cost effective, more reliable product, right? That you need to think about. And then you need to build with fail-safe features. What happens if suddenly the connection goes bad? Let's say you are designing something to agricultural product, let's say to automatically supply water to a plant, right? So you may be collecting data and connecting to a cloud service and getting the data. What happens if the connection goes down, right? Will the plant will not get any water, or it could go down at a state where you have opened the tap, but before closing it down, when it gets the correct amount of water, when it will overflow, right? Those things you have to look at, right? So you always need to have a default fallback plan. So your situation may be, if the device is not connected to the cloud, if the connectivity is not there, there's a default amount of water that you provide, which is a fail-safe one, sufficient to prevent the plant from dying, but not to overflow, right? And a timeout. When you open the tap, if you don't get the command from the server saying that okay, the water level is okay, you have a default timeout. After that timeout, you anyway shut down the tap for safety reasons. So those kind of things you need to think when you design. That makes your device to be fail-safe, right? And then you should design this device to support only the required functions, right? Sometimes we try to do everything possible with the device, but every device has an intended function, which will also translate to intended market, because someone is buying this because he has a need, right? So you try to optimize to that one, and by doing that you can save the cost, you can reduce the cost, right? So just to get a glimpse of this is the internal architecture of a typical computer. This is what you get in an IoT device. So see the simplicity, right? I mean, this has huge, this is very simple, so this is the simplicity, right? So the main objective, which I say usually say, is that designing a IoT device is the KISS method, KISS method. Keep it simple and stupid as much as possible, right? Try to make the device simple as possible and use the simplest most. Someone says it's a stupid technique algorithm of doing that, but if it works, that is the best algorithm for that, right? So keeping it simple and as much as possible will make sure that it is reliable and efficient. So if you to do that, all you have to deal with the computing power. Keep in mind that when you design IoT device, the computing power will be very limited, right? You are not going to have all the computing power that you need to run that. So you have to be ready to work with this minimum amount of computing power that is available, right? And also, so typically, as I mentioned earlier, you need to divide your task between what to do in hardware, what to do in software. Now, for example, let's say the watch. Now, it need to measure your heart rate. It need to measure your blood oxygen, right? So, one option is that you can add a heart rate sensor and a blood oxygen sensor to the device. Two sensors to sense both parameters, right? So that will ensure your software is simple, because you simply get the reading from the sensor and send it back, right? Other option is that you only have the blood oxygen sensor, and from the variation of blood oxygen level you predict the heart rate. So you do it in software rather than having a hardware device. So there are benefits and disadvantages in both options. If you have two sensors, your software becomes simple. You can go with a very low end processor, your processing power is reduced, your processor power consumption is reduced. But on the other hand, now you have two sensors, two connections, cost is high, space, you need more space to have both sensors. The sensors might need more power, both when you get together, right? On the other side, if you have one sensor and try to derive the other from the sensor itself, then what happens if that sensor fails? You're not getting any reading. But if you have two sensors, at least you get one of the parameters coming out. So all these things you have to put in balance and see, for my application, for my product, which is the best option, considering not only the technical things, also the financial, marketing, and all the entire domain. Right? Whether if I put 2 sensors, will be a plus point in marketing there, or whether that will increase my cost so that my competitor's product becomes much cheaper than my one. So all those things you need to look at when you take the decision, and whether to do this processing on your side or on the cloud. Right? And that's also, the cloud also has a cost. When you put more things into cloud, you need more space, more computing power, more resources in the cloud that you have to pay. Right? So you need to look at this holistic view to get that. Not only that, there are also other aspects that you need to look at. Right? One is security, because IoT security is becoming a very important thing. Right? Security means how to protect access to the device. Nowadays, your bank, there's a OTP coming for your bank account transaction. So if you lose your mobile phone, your OTP might go to someone else. Right? You might use your mobile phone, or you might simply use your SIM card. Right? And someone might somehow get a replacement SIM card for that before you do it, and he will start getting the messages. Right? You give your phone to repairs. Right? And how many of you will erase your data in the phone when you give it to repairs? Right? So the repairman has access to the information. So that can lead to various things, security issues. Right? And physical security of the device. Right? Physically, how the device can be secured. And lack of visibility, because most of the things in the security domain, in a device you don't see it. Right? There may be vulnerabilities that are not seen. And also you have a lack of controllability, because it's not easy to shut down this. And then also the privacy. Right? I mean, how it could protect personal privacy of a person. I mean, because you may have in the watch someone with a Wi-Fi gadget which can connect to the phone might be close here and extract certain information from here. It might extract the Wi-Fi connection, because now it is designed to get the Wi-Fi connection information from your phone. So that can create a vulnerability where someone else might also connect and use your Wi-Fi phone without you knowing. Right? And then data exposure, how you protect data in your device from someone from accessing. All those things are there. Right? And then technology issues, because when you select a particular technology, you have to keep in mind that IO is a relatively young technology which keeps on evolving and changing. So when you select a particular processor or select a particular component, check whether this is at least to mature to some level, because next year there will be a new component coming in and your old component may no longer be working. Right? See whether. Now Arduino is a platform which has been there for a long time, so it's much more mature now. But if you take ESP, it's also mature, but not to that level. And there are many other pies coming, like Raspberry Pi, there's Orange Pi, Banana Pi, various other things coming, boards. I mean, how long those boards will be available in the market? Raspberry Pi has been there for a long time, so it's more stable. Right? So other devices may not be available like the same thing. So when you try to put into a device which you try to market, you have to think about that as well. But despite of all these risks, there's a huge potential for IoT. This is a projection for IoT market, right? So by 2027, it is expected that there will be a global market of $483 billion for IoT devices. Various aspects of IoT devices, security, hardware, services, and so on. So there's a big potential ahead, right? Only thing you need to do is be concerned about taking the correct approach, technically correct, security-wise correct approach, marketing-wise correct approach, product development-wise correct approach. If you grow with the correct path, you can harness part of this growth. So my time is running out. So with that, I'll stop my presentation. If any questions, I think we will lead to the last session so that at the Q&A we can answer them. Thank you very much.
Thank you, Professor Chazura, for your valuable insights.
Moving on to the next session of the event, we have the pleasure of introducing Ms. Dashin Fernando, a senior electronic engineer at Zone 24/7 and a visiting lecturer at the University of Sri Jayawardhanapura. He is going to speak on product development and testing. Ms. Dashin, the stage is yours.
Right. I like having a wireless mic because I want to walk towards lovely students, then ask questions and engage. So let's make this an engaging session while we do this. Okay. So good morning, ladies and gentlemen. A bit sleepy. Good morning, ladies and gentlemen. Lovely, great. Okay, so today my name is Ashin Fernando and I will be doing a session on product development and testing. So most of you have, I think, on the way to develop an IoT product, and some of you have already started. So product development and testing are two important factors we're going to discuss, because when you're finalizing a product, one thing you do is testing. Testing is very, very important. And also, some of you develop products and then you think this is it. Most of you here are undergraduates. And in the undergraduate level, we assume putting some wires together and some modules together, it's a marketable end product, or that's the end. Or is it? There is more to product development than just putting a controller and some sensors and some wires on a breadboard or even a prototype PCB. So let's see how we can go beyond that. Now, before we start, this is, ladies and gentlemen, actually a Boeing Dreamliner, right? Give me a second before I can set up the clicker so that I can see if it works. Right, lovely, it works. So this, ladies and gentlemen, is a Boeing Dreamliner, right? Some of you might have seen this, some of you might have traveled in this. Anyhow, this is a Boeing 787, I think, if I'm not mistaken. Now, during the manufacture process of this aircraft, right, there was a little glitch in the firmware where nobody noticed. There is a keep it going. This was the actual incident that happened in the year 2015. Why? If you increment a variable every 100 milliseconds, right, after exactly 248 days, this variable reaches this 4 billion value and overflows. So these CS people know what Stack Overflow, how dangerous it can be, and it corrupts the entire system. And Boeing had to figure this out at the end because nobody thought that this was happening. And somebody in the testing process of this Dreamliner missed it, right? So testing, ladies and gentlemen, is very important, and it plays a major role in your product. And if people like Boeing can make mistakes and forget that there is this variable and this happens, what about us? So we have to take extra caution and give prominence to testing. With that, the agenda for today is I will be first talking about the importance of testing, the types of industry testing, right, that is available today. And also at the end, we'll be talking about embedded systems design process. To start off, now that I spoke about testing, why do we need testing? Can we have a few answers from the audience? I hope the mic can reach the audience. Anyone. We have students from University of Murtua, students from all universities in the country. So anyone, why do we need testing? It's a very generic question. I think that's the end of the line. Yeah. Why do we need testing? Can anyone give an answer? It's a very simple question. Students?
To make sure the product is working.
To make sure the product is working. Lovely. What else? What other benefits that testing gives us? Anyone on this side? So there was a lady from this side who gave an answer. Anyone?
Does the product meet the user's requirements?
Does the product meet the user requirement? Great. That is one important thing. Another important thing. Find faults, yes, debugging purposes, and I just did this. At the end of the day, testing will save us money, yes, because at different stages of the product, when you find out bugs, right, fixing them costs. If it's a firmware, yes, it costs just only labor. But some of y'all are developing hardware products. Then it costs extra resources. Maybe another iteration of the PCB is required, right? So testing, at the end of the day, will give us these benefits in a nutshell. Right? So everything you told, ladies and gentlemen, falls into this category. It will give you reliability and assurance of your product, definitely, right? And it also gives you a quality validation because you set a certain standard, you set a certain quality, and it will validate your quality, right? And compliance and standards. So this section will have a chat, right? So most of you all are developing products, and some of you might be aware of compliances, some of you might not be aware of compliances. For example, the most famous compliance in Sri Lanka is SLS, right? That's a standard, right? To meet up with the standard, every product and service has certain requirements, right, to be SLS certified. So similarly, there are other standards, so we'll have a chat about them as we go along, right? And also cost and time saving. Now, Boeing, when they had this problem in the Dreamliner, do you think the pilots or the customers were happy? Right? What if they never found it out and in the middle of a flight, this reboot happens? What about the danger of the passengers? What about the danger to the crew? What about the danger to the people, the airport? So much of things. It's a very serious thing, right? So testing is very, very important, and we need to give it priority, right? And it should start not at the very end, but as you go along, you should plan for this. So I just broke down some of the main industry tests so that we can have a discussion on it. So the first thing is both bring up testing. So I was told that everyone here, most of us here who are participating in the competition, we are building a IoT solution. Raise your hands if there is a hardware part in your IoT solution and you are working on it. It's a hardware component. Yes? It's a hardware component. Good. So I think thank you very much, there's about 80% of us who are working on hardware component. Raise your hand if you are building a custom PCB for this or a circuit board, or you're using you're building your own PCB circuit board for this. Okay, that's about 10% of this. Perfect. And the rest of you, I'm pretty sure you're using a breadboard and a microcontroller, right, to work. Good. Now, the moment you bring up a PCB or the moment you bring up your design, what do you normally do? Do you just straight away power it on? Right? The moment you get it shipped from China or any other factory, you fabricate your PCB and you put your components in. What do you normally do? Do you just power the entire device? Is that how you do? That is not recommended. Right? The moment you bring a PCB or a new setup, right? If you are having a new prototype design, you don't power it up directly. There is a set of procedures and tests to do, right? Before you power your device on. These are called board bring up tests. Now, whenever you have your product, there are several key components. There's a power supply, there is the peripheral devices, there is your microcontroller. And of course, if there is external memory, there is your external memory, right? Now, before you bring up the board, you need to test each and every one of these segments separately, right? So, you have to check if the power supply is properly working, right? If it's giving the correct voltage before you plug it, right? If not, you'll see some smoke, something burning, and everyone knows that legendary smell of burning electronics. You all don't want to do that, especially before your evaluations, because when the evaluations of the product is close, even if it's a final year projects, when we are close, what we do? We are in a rush. You plug in something and then you realize some of your key components have been damaged without even knowing. That's because we rush and we do not follow these steps. We just plug it in, we just trust our instincts. But no, we have to verify the power supply, then the clock and oscillator, right? If you're having a PCB, you might have to use your own oscillators, own clocks. You can use a oscilloscope to check that, right? If there's a correct frequencies coming in, and of course peripherals. So you don't directly plug in the peripherals first, right? You check if the correct voltages are coming, if the correct communication is happening, and then you plug in the peripherals, and finally the memory. So there are different stages. There is initial memory stages and the working memory stage. So you check it in sections. You don't do all of this as once, because once you damage, you're done for. Especially when you're close to an evaluation or a demonstration. Right? I've seen this happening at uni. I've seen this happen to my friends. So be careful. It's very important that you do it in a gradual process. Right. Since most of you are students from CS, firmware is something very close to you, right? So firmware also, we have testing mechanisms, right? We just don't do haphazard development, right? So some of these words might be very familiar to you, but I'll just recap on them. How do you debug or develop firmware and debug it properly? So debugging points you might know, but what are these? Assembly window, watch window, stack window, register window, memory window, and what's a watchdog timer? Raise your hands if you know what a watchdog timer is. Nobody knows. Oh, there's one. There's just one student. Okay, great. So let's start with debugging points. So I hope you know what debugging points are. There is a point that you can mark in your specific firmware, and as it runs, you can monitor at what point you hit the debugging point. That's very straightforward. After that, if you're using an IDE, right, depending on the IDE you are using, you can check the assembly code. You can also check the status of the firmware, where it is running if you pause it at any point, right? You can see the stack status, the register status, and the memory status. Why are these important? Because if you are reaching the limits of your processor, right, if you are running it on the limit, right, then of course we have limited resources. Then your performance may be hindered. Your expected performance will not come. So it's very, very important that you know the limits of your processor and you have healthy usage limits. If you have 100, you all never use 100% process capacity. Why? That can be harmful. It can overheat, power consumption, And power is a very critical factor in most if it's a battery powered IoT device. Right? So there are a lot of things to consider. Right? And so these things help you to monitor the status of your firmware. Right? And will assist you in the debugging process. If there's a stack error, you can see there is a stack overflow, there's a memory error. Right? Similarly. Right? And if there is a very critical change, you can go to the assembly level of the code and do the changes. Right? So what is this watchdog timer? What does the watchdog do? Forget about the timer, forget about the application. What does a watchdog do? A watchdog is a person or an animal or a thing who will look if there is any issues. Right? If you have watchdog in a house, right? If there is anything wrong, if there is any burglars coming in, or if there is anything different in the environment, the dog will start barking. Right? That's pretty straightforward of a watchdog. So similarly, in microcontrollers, there is a timer called watchdog, right, who will be watching if the device is idle or if the device is not working, and will come and reset or interrupt the entire process if he feels like there is something wrong. This makes sure that the device isn't going to idle states. Right? So sometimes it's okay to have the watchdog timer, but most of the time we disable the watchdog timer because, especially if it's an IoT device that is not, it's in a low power stage for a very long time and not being used a lot, sometimes this watchdog timer can cause errors. Right? So we sometimes, most of the time, we start with disabling this watchdog timer. Right? Because it can give erroneous resets. Right? We call them brownout resets. Right? Not power cycles, not complete resets, but brownout soft resets to the device, and which cause problems. Right? So what are the preventative actions to avoid bugs? Code reviews and coding standards. So there is something called the MISRA coding standards. If you can go and take a look at it. Right? So those are specific firmware coding standards. Right? Specifically made for C++, that is for others as well. Right? And they tell you what are the best practices for firmware. Right? Because when we name a variable to declaring variables for functions to everything, right, there are specific standards that we can follow. And these standards help you to debug. Right? I hope there are nobody who names their variables int x, int y, int k, just single letters. There are people who do that. I don't know. So please don't. Right? Because nobody knows. You will know. If you write the firmware, you will know. But what about the next person who's working on the project? Or what about your friend who is also working with you? How will they know what this variable does? So from that level onwards, there are different ways that you can name variable, different styles, camel case, snake case, your CS students. So those standards are very, very essential, even if this is for a competition. Because if you maintain those standards, right, when you go into the industry, it will be very helpful. Right? So at the end of the day, you all will be going to the industry, and we specifically look for these standards because you will be working collaboratively. Right? Unless you are a freelancer. In the industry, 99% of the time you will be working collaboratively with senior engineers, juniors, colleagues, and if you don't maintain the standards, the other person will find it hard. So it's very important to maintain the standards. And also test driver development, right? So we should make firmware that can be easily tested, especially unit testing. How many have heard the word unit testing? Unit test? Okay, so I'm asking just to know my audience so that if I can explain or not. So okay, we have about 10, 15 students who know. Good. So unit testing is the concept where we write a firmware or a specific function to test a specific segment of your product. For example, let's say you have a ESP32 or something that is communicating with a memory, right? like an EEPROM, right? And you write a specific code to test the EEPROM within your original firmware. So when you initiate a test process, that code may be writing maybe it will write a random variable, right? A known variable or random variable to the EEPROM and read it back to check if it's readable from the EEPROM. Very simple. And running that specific code will let you know if there is any issues in your EEPROM. Right? And if it returns okay, right? If it returns alright, if it returns okay, that means your EEPROM is working. And if it doesn't return okay, that means there is something wrong. Either there is something wrong with the connection to the EEPROM or EEPROM in itself is corrupted. Right? So that is how you figure that out. So unit testing is important. And of course static code analysis. That is a concept where we analyze code, right, without running it. We just visually analyze. So there is a tool for, I still find it difficult how to read that, so I'll just leave it to you. It's a bit, but that is a tool which analyzes code without running it. Right? So it's very important. And of course embedded security testing. If you know that you have to upload firmware, there are JTAGs and there are firmware uploading portals, like there are separate portals to upload firmware, right, to your code, to your hardware, right? So normally when you're having a final product, we don't expose this, right? And then there could be security breaches, right? Especially if there is a bootloader and then if there are external communication devices, right? And you can also mechanically secure your device. So I'm actually working on a current project in my current workplace, which is sold 24/7, right? They develop firmware. I'm actually in the project itself. If you have seen these units that you put in the credit card, if you have gone to a supermarket, right? There's a specific POS unit, not the POS unit, but a separate unit where you insert the card and you do the transaction. So we actually support for a US company for to do the firmware. The firmware meaning the part that actually reads that smart chip and the magnetic stripe. So there's a smart chip, there's a magnetic strip, as well as there is NFC, right? When you tap and go, right? Which is famous now. So that happens from the firmware end, and it communicates to the Android side. The kiosk is running on Android, while the hardware is the hardware is read from a firmware component, right? The card is read from firmware, and it passes to the hardware. So in this device, for example, there is hardware level security, where there are encryption keys, right? And if you try to disassemble this device, this encryption keys will be damaged and the device will be damaged. Even if you try to remove a screw, there are hardware level things that will destroy the memory and the firmware if you try to disassemble it, right? Even if you try to poke it in. So that kind of security is implemented in some hardware devices, depending on the criticality of it, right? So it's just an example I told you, right? So yes, and of course there should be an activity signature, right? Which means if there is anything that is running, then there should be unique signature to authenticate it, right? Two-way authentication. If not, some person can maybe remove the already available EEPROM and tap in to an SPI bus and then use their EEPROM. So things like that can happen. All right. For IoT people, some of these logos might be very familiar. How many of you using MQTT in your product? Okay, right, that's a lot. Wi-Fi? Okay, more hands. Bluetooth? Few hands. And anyone using Zigbee? Any of you heard about Zigbee? There's one person using Zigbee. Good. So these are some logos you might have seen a lot as IoT people, because these are communication protocols and wireless, especially wireless. Most of them are wireless communication protocols, and I2C, CAN bus and SPI and TCP/IP are wired protocols. How many of you are using TCP, like connected devices? Just also to raise up hands. Anyone who is using? Okay, there's a couple of people. Okay, good. So when there is network that is used, wired or wireless, we need to test this, right? Some of you will be using this because that is the latest available. Some of you might be using because that is the coolest technology to use. But how many of you actually considered your bandwidth requirements and your speed requirements and reliability requirements? Right? As Professor mentioned earlier, right? Sometimes the stupidest solution can be the best solution if it works, right? And just because a specific communication protocol is the trend or the coolest protocol available, right, doesn't mean you should use it. There are cheaper and more reliable alternatives there. Right? So when you're using all of this, it's important when you test this to the limits. Right? Time is also running out, so I need to adapt. So test these protocols. So how are we going to test each of these protocols? I'm not going to go detail into each technology and how to test them. But there are tools, right? Use tools available. There are network testers, you have oscillators in your universities, right? If you know, you can test all these wired protocols can be definitely tested using an oscilloscope, right? If you know what you're doing, if you know how the wired protocol works, yes. Of course, if it's a network protocol, like in TCP, Ethernet, then definitely you can use a network tester. Right? If you know that your bandwidths are working, if the data packets are coming in, right, you can test it. And also, you have to design your test for these cases. Specifically, if you are using your Wi-Fi, if you are using your MQTT, how are you going to design your test cases? How are you going to organize the nodes? How are you going to communicate? Right? So you should know how to design them for your application. Right? Because some of these tests are very broad, right? And for your specific device, you need to specify, you need to narrow it down and see what you can do, right? I'm not going to go much on the communication protocols because I'm pretty sure you're aware of it, but this is something very important. Industry compliance. How many of you are planning to market your product? Let's say I'm going to build something really cool and I'm going to market it one day. I want to see my device being sold in the market one day. How many of you have that vision? I want to see my product being sold. That's it. Okay, cool. Good. So if you are, then these industry compliance tests are very critical for you. Why? You might have seen some of these on your devices, on your laptops, on your smartphone, chargers, right? On most digital equipment today, you might have seen some of these logos, right? The ISO certification, the safety mark, ROHS compliancy, lead-free, right? And PCI, DSS. Right? And there are many more, right? So these compliances are critical depending on what market you're going to sell. If you're going to US market, Europe, right? Asia, right? East Asia, China has their own thing. So if you're planning to sell your product, depending on your region, right, you need to know what compliances you need to focus on. And you can't like halfway through development, you can't be like, I want to sell it in the US. No, you can't. You need to plan where you're going to market, at least at the first 10% of the project. Why? Because every component you use for your project, right, needs to have these regulations that is specific for that region. Right? So specifically, so let's go with some examples, which is the FCC. How many of you have seen the logo at the end? This one, FCC. Yeah. Most products you see have FCC because that is for United States, which is a huge market. And if you don't have this FCC regulation, you cannot sell in the United States. Right? And FCC is very wide. They have so many other tests, right? So example, if you're using a wireless module, if you're using a Wi-Fi module, that Wi-Fi module bandwidth has to be within FCC approved rates. Right? If your product is here, and because of this, your product, if this projector starts flickering, then there's a problem, right? Right? So you might have seen when you have blenders, some blenders low, if you get something that you can relate, right? Old blenders, if you turn them on, do you see TV is flickering? Blender on karo, your TV flickers, right? Yeah. So can you sell that kind of product? You see there's a problem there. Can you sell that kind of product in an international market? No. So if your product is here and there is from your product there is an effect to this projector and this phone over here, then there is a problem with your product. Right? So your product's bandwidth, your product's radio waves cannot affect the products around. So that's why these regulations come in. And ROHS and lead-free are also two new environmentally friendly compliances, right? ROHS means there is no harmful products, right? And lead-free is more like a subset of ROHS where you specifically have lead-free components. Now remember, when you're going lead-free, you can't say at the end of the product, I'm using lead-free. When you're designing your circuit, you need to make sure that you use lead-free soldering, lead-free techniques, lead-free paths, right? So let's say you're using a microcontroller, your entire PCB is lead-free, but the microcontroller has lead. So can you say that your overall product is lead-free? No. So then selecting the microcontroller itself, you need to make sure that you have lead-free, right? Maybe everything is lead-free, you have one small sensor that is not under this compliance. So can you say your entire product is lead-free? No. Similarly, when all of these compliances are required, every component should have this compliance to say that your entire end product is that. So I just got an example. This is actually a product we built in our company, which is Zone 24/7, right? So in this product, if you see, there is a RFID module, there is a RF module, and there's an IoT gateway module, right? So for each of these RFID modules, there's a separate FCC ID. So for the RFID module there's a FCC ID, for the RF module there's FCC ID, and for IoT gateway there's FCC ID. And because of all of this, overall we can say that the device is FCC approved, compliance. Why? Because the modules we chose are FCC compliance. So because we chose these modules, we can say it's FCC. If one of these modules were not, then we had a problem. So then, now since these modules are already approved, we don't need to test them. But overall we need to test the device, and then we can say we are within compliance, right? So once you register in any of these, from ISO to any compliance, you will get your registration number, which you need to publicly display, right, in your product. That's why I had this example. So before, also let's talk about two tests that you can do for your product. So one test is the halt test, test to fail, right? So here what we do is, in the gist, we test until the device fails, right? We test until the device fails, right, to the breaking point, right? And we rigorously test it. So basically, if you have a switch, right, there are two main companies that manufacture switches, for your house, home switches. Right? The switches where you turn on or off lights. So they give lifetime warranty. So how can you give lifetime warranty? So in a lifetime, if you break down on a daily basis, you know the average number of times that a switch will turn on and off. Right? So if you multiply that maybe 20 years, 30 years, you can mimic that usage, right? And see maybe, 1 million turn-ons and off, 1 million cycles, 2 million cycles, 40,000 cycles, and you can mimic that entire 20 years and see at what time it breaks. Right? So the breaking point is called the halt test. So you test to fail, right? And you find at what point it fails at the different aspects: stress, cycles, current, things like that. And then there is the hash test, highly accelerated test screen test. The hash test is done within the operational limits. So I just had some details as well. So what we do is, we don't break it. We do the test to know that it meets the requirements that we said it would. Right? if this project is supposed to, just an example, supposed to work in this range, if it doesn't meet with the works at this range, then there's a problem with the definition of the projector specification, right? This project won't work underwater, right? So we can submerge it and you can see it breaks, but we have specifically mentioned it works at a distance of maybe let's say about 10 meters, right? And that needs to meet. That's when the hash comes, right? But if this project is working under 125 Celsius in a heat room or in a cool room or outdoor when it's snowing, those are halt tests to see at what time this will stop working. So to get a better idea, I have this little graph which explains. So during the halt test, there is an upper destruction point and the lower destruction point. We work to the destruction level, right? We work till we test it till it breaks. So upper meaning the highest conditions and then the lowest conditions. The highest temperature, lowest temperature. Highest voltage, lowest voltage. Highest frequency, lowest frequency. And after the halt point, your device is no longer operable. It's permanently damaged, right? But during the hash test, right, we don't go to permanent damage point, but we test to the end of the specification. If it's a speaker, if it works from 20 Hertz to 20,000 Hertz, we check if 20,000 Hertz work and we check if 20 Hertz work. But actually your music might not go to that range. So this is the normal operating range. It will never go there. But we check the mentioned ranges. I hope you get it now. But in the halt, we check it to the breaking point, which should be ideally beyond the hash level, right? So try this test and do them. So the last thing I want to cover is embedded systems design process, right? So for those of you who raised your hand saying, I want to market my product, I want to see my product being sold somewhere, this is the process that you need to follow. So most of you might be somewhere here or somewhere here, right? So you might have thought about the concept, right? This is the thing that comes to you in your sleep. Like when you're having a wash, you think, okay, what if I had this device, the idea in your head? That's the idea, where you brainstorm and get an idea. And then you do the proof of concept. So most of us undergraduates, we do this. We have a breadboard and some wires connected, and we call that a product, right? I want to build a cheap vacuum cleaner. What we do, I get the parts and build it on a board or a table and tell that's a cheaper alternative to vacuum cleaner. But what you don't realize is you need to go through these stages for production level, and that's where the actual cost lies. You need to in the electronic verification stage, you need to do a PCB. In the design stage, you need to make sure your vacuum cleaner looks good, right? If your vacuum cleaner is this big, like 1 foot by 1 foot, will anyone buy it? No, it should look sleek, portable, right? Easy to carry around. So that's when the design constraint comes. And the electrical constraint, if your vacuum cleaner uses 15,000 volts, can you sell it? You can't. You need to make sure it works at 230. Or if you're having a mobile vacuum cleaner, then a battery powered, right? And then production verification. Now you do all of this, and while you are trying to produce the vacuum cleaner, you figured out that the microcontroller you are using is hard to solder, right? Or is not available in the Chinese market, right? When you're purchasing, right? Or in the production process, your design process, your design of the vacuum cleaner is so hard to assemble. Right? You have like 10 screws instead of 5 screws. You have added 10 screws, which is better. But when you're assembling, it's harder to assemble, right? So then your device is not producible, and especially when you go for mass production. Mass production meaning, so producing means you have batches of 100, 200, 1,000, that's it. Mass production means you have batches of 10,000, 20,000 or 100,000 units coming out. At that level, instead of 1 screw, if you have put 2 screws, the time loss, right, the loss is multiplied by 100,000, right? Instead of 1 screw, you have used 2 screws. So instead of 100,000 screws, now you need 20,000 screws. So 200,000 screws. So every small thing matters when you go to mass production. Every second matters, because when the time you take to insert 1 screw and time you take to insert 2 screws, is double. So the time to produce the devices will increase. So if your throughput is what, 10 devices, so they say Toyota manufactures, I don't know, every 1 minute or every 30 seconds there is a car that's put out. Right? It's their production rate. I'm not sure of the actual numbers, but it's something or somewhere around that. But if they have one small change in their production line, it can increase a couple of seconds and it will make the whole throughput slower. Right? So production, it's very important to consider these in your production stages. So normally I talk about this a lot, but I want to focus more on testing, right? So there is a lot more that we can discuss. So there is a Q&A session, so if you want to ask questions on the production cycle or testing, it's open. So before we close off, right, I want to leave you with this quote and this QR which has my contact details, so if you want to scan, right? Automation applies to an efficient operation. Inefficient operation will magnify the inefficiency. So make sure whatever the type thing you automate, your IoT solution, right, for all these IoT people, your designers, you're designing for some solution, whatever you apply your solution, you make sure that operation in itself is efficient. Just because you want to make a solution, don't make a solution. Right? Make sure that that solution is actually going to solve that problem and is going to be very efficient. So thank you, ladies and gentlemen, and I would like to hand over controls to our. Thank you very much.
Thank you, Mr. Ashay. And now it's time for a short break of 20 minutes. We have arranged refreshments outside. Please do wait until our team ushers you outside. And a small announcement, we have arranged, you can pre-order the delegate pack and purchase stickers during this interval. We shall reconvene at 10:40 a.m.
Welcome back, everyone. Now it's time for the third session of today's workshop. I would like to invite Mr. Sumedha Rubasinghe, the founder and the CEO of Entra, on stage to speak on IoT startup lessons from the past. Sir.
Hi everyone, good morning. Yeah, still it's morning. I've been listening to Professor Chatura and Ashen speaking, quite interesting. And what I thought of doing was something non-technical, right? More towards how to convert what you are doing into a business. Right? I'm not sure how many of you are interested in doing that. Can we have a show of hands? Yes? Okay. So this is not something for everyone, I would say. Not everyone would, even like only 4 hands came up, right? I think even among yourself at this age, probably you have thought of it as something what would I say, something challenging, difficult, something that you don't know, maybe, right? So what I want to do is I want to explain some of the key areas that I myself have discovered as an engineer when together with a couple of others when I founded a particular business that I'm running these days. Okay? So okay, to start with, now I don't know whether you guys know about this. I thought I'll start with a question. How many of you know what is the most critical factor when it comes to a business being successful? Anybody wants to take a guess? If you want to do a business and if you want that business to be successful, what is the most critical thing about it? Anybody wants to take a guess?
Customers.
Okay, customers.
Patience.
Sorry?
Patience.
Production.
Patience.
Patience. Okay, patience. Customers. What else? Anybody? Sales. Okay. Okay, I'll. This actually is coming from a TED talk. The TED talk is here. There's a different research that is supporting this as well. Right? It's mostly timing. Right? So everything that you guys have been mentioning are kind of related, but when you look at everything else, funding is right at the bottom. Right? Business model is somewhere there. Idea, the team, execution. Right? Timing is the most critical thing. If you guys want to read about this, there's enough material on this, and also figure out what happens to YouTube, what happened to YouTube, how it came into the business, and what happened to the company that was doing something very similar to YouTube that died 2 years before YouTube came into the picture, due to the fact that they didn't have, the world did not have enough internet at that time. Okay, now with this, I'm going to switch into a different approach. Now, whatever that I'm going to tell, right? These all based on my experience. So there can be many other interpretations, many other ways of going to the same place, right? But this is basically my experience, and I have just put that into a particular structure. So to start with, a little bit about me and what we are doing. I ended up like deploying the very first production system into a bank in Sri Lanka back in 2001. So that's probably 1 year into my 1 year after I started working. Passed out in 2003. Right? So you probably guessed that I have been working while I was a university student, and been at several places, and then was at WSO2 for 13 years. And within WSO2, I was lucky enough to be product lead for 7 products. So developing a product is kind of it's an art, different art itself, right? All those are software products. And then started this particular company, Integra, which is almost like 6 years to this year. So at Integra, what we do is there's this particular vertical at WSO2. Now this used to be the picture in 2018. This slightly different at WSO2 now, right? But the last vertical that you see, right? This particular vertical we took it out as a separate company because we wanted to develop IoT solutions on top of this device integration platform. Right? So how this is different is now Professor Chatura and Ashen, they were talking about hardware specifically. Right? Now on top of the hardware, if you remember that one of the last slides from Ashen where you had the whole life cycle. Right? Now for the hardware to be a complete solution, you may not have to end it with the hardware. There could be a lot of other things. Right? So for you to develop that solution, you need to have a proper solution, proper platform stack, so that you can do a proper solution building. So typically an IoT platform is something like that. And what I'm going to talk about is now, even though my title has IoT startup, I'm not going to talk about IoT part of it. I'm just going to tell you some of the key topics that I feel as interesting or important when it comes to developing a sustainable startup business. The term startup is there because I'm assuming that none of you guys are doing your own thing at this point, right? So the first thing is, the first section that I want to talk about is few key ingredients. Somebody mentioned this, sales. Now, if you don't have a cash flow, you can't do anything. Right? You can have a very crappy business, right? But as long as somebody is paying you money, and if that money is greater than your expenses, you can keep on running that business, regardless of whether you are having employees, whether you are having good people, whether you are having good products. None of that matters as long as you get a cash flow. Right? So people can tell any different things, but if you have a cash flow, and if that cash flow is more than your expenses, you can keep on running. Right? Then the next thing is, if you really want to, keep on doing that, right? You need to have a passion. Otherwise, you'll do that for 1 year, 2 year, 3 year. After that, you'll be like, okay, what is this? Right? So if you don't have passion on what you need to do, what you are going to do, don't do it. Okay? And the other thing is, with the passion, now most of the time these days you would hear people migrating. Right? People letting we have to go out. Right? But if you are from a business mindset, and if you have read enough, if you have thought about the problem enough, you would realize that any market, any situation has an opportunity. Right? And if you are skilled enough, you will find a way to grab that opportunity. So now for everybody, anybody who's leaving thinking that that this country is not good enough, right? What they're actually doing is they're actually creating a great opportunity for the people who are staying. That's one thing. Because like all the people who think, who can't, who can't do something, is leaving. What it means is you're going to end up with a set of people who can do something. And it's going to create an opportunity because set of people who were able to do certain things are no longer in the country. Okay. So once with the focus, once you have the passion, you have to have the focus. I mean, when you are running business like this, it's very easy for you to lose the focus, come up with a lot of solution ideas, lot of things that you want to work on. Right? Now, yes, theoretically it's practical. It may be like all those ideas could be very valid, right? But you can't be focusing on 10 different things. Okay? So having a focus about the particular problem that you want to solve is very important. Okay? And avoiding distractions. I mean, when it comes to these days, there are plenty of things that are going to that demands your attention. So focusing, having a proper focus on what you want to do is something very key. And while you do that, while you have the passion, while you set your focus on certain things, definitely there are going to be failures. Things are going to fail. Right? We should create self-doubt. All my batchmates have gone to other places. They have they are in big corporates, or they have migrated. I started doing this, or now this failed. I'm going to create a self-doubt, which is, I just wanted to share that it's normal. It happens, right? And if you are strong enough, you would, if you have this, you would get out of it. You will find a way to learn from your failure and move to the next level, or do something else. Okay? So the next part is, now up to this particular section, I call those key ingredients. If you want to have your own business, if you want to develop your own business, right? Some of the key ingredients. Okay? The next part is about, now you can't be doing that on your own. So you need to develop a team, right? Now for you to develop a team, you need to first of all go in and be able to tell people, okay, I have this particular idea. So it starts with an idea. Right? You need to have a clear definition of what your idea is, what you want to do. Right? And that's why I said it starts with you. Right? If you are not clear of what you want to do, how can you explain it to somebody else? Right? And then probably before going in and explaining that to someone else, you probably need to do an idea validation. Is this something that is going to fly? Are there alternatives? Right? Is there a market for that? Is this something that people would pay money for? Remember, if you don't have a cash flow, what's going to happen? And can I actually repeatedly do this? Right? So validating your idea, right? And having an idea is just nothing, right? This is basically what Walt Disney says, right? You just have to, after a certain, of course you need to talk, you need to discuss, but after a certain point in time, doing is the one that is going to have a biggest impact. And for you to do that, after a certain point in time, you will realize that you alone cannot do that, or two people who have started the thing cannot do that. So you need to form a team. Okay? So what it means is you need to have, you'll have people obviously the founder, the co-founder, then people who joined with you, the founding members, employees. You may have to outsource, right? So different types of responsibilities for which you need to hire people into your team. Okay? And with that, it's very important to understand and define that each of those team members are having designated responsibilities, right? And making them understand, for this particular business to be successful, this is your role. This is how you need to think about it. Right? because otherwise, like if you employ people who just comes for the salary, it's not going to work in the long run, because they're just going to like do a specific set of checklist items and be done with it. So making sure that everybody understands what everybody is supposed to do, right? So that holistically you achieve whatever that you want to achieve. And having a proper balance, right? So can't be, yes, you'll end up having brilliant people, but they can't be jerks. They can't be, like letting other people down. They can't be, talking, telling things like, okay, I'm the person who know about it, you don't know about this, keep your mouth shut. Right? Can't be that. You can be brilliant, but if you don't know how to work with other people, how to get them motivated, how to get them engaged, how to educate them, right? You're nothing. Right? So make sure whenever you are hiring, if you are a person like that, you can't go a lot further, right? And whenever you are hiring, or whenever you are like bringing members into your team, make sure that you don't bring people like that, because with a person like that, the other members of your team is going to leave. And also, like when you are doing this, if your idea is taking a significantly long time, try to understand some of the individual aspirations as well. For example, if you are like getting someone for something that you think that is going to take 3-4 years, right? If the person is having a migration plan after 2 years, you're going to end up having a big trouble, right? Because initially when you are building a business, it's very, you don't have duplicate people doing the same thing. You can't afford to do that. Right? So it's very important that whoever that you are hiring are having some similarity in terms of career, life, money, opinion, health, those type of things. Right? So for example, like health or opinion, right? If you end up hiring 2 people, or getting 2 people who want to like sleep and just keep on working, but then there's another person who's conscious about the health, who wants to take a proper break, proper sleep, it's going to create conflicts, right? So yeah. And also have some advisors that you can trust, who are independent, right? Who can tell you, who can guide you, right? Who can give you a different path to think. So that part is about certain key aspects when it comes to team building. Okay? The next thing is, now once you have the team, you have to focus on the delivery. Right? So if you are starting something new, right, having an MVP, minimal viable product, is something very important. Without going into very costly operations, figuring out what it is, what is the minimum value that you can provide, and taking out into the market is something very important. And being able to define this MVP is something very critical. And on top of it, defining your business model on how you are going to generate that cash. What's the value that you're going to cash flow? What's the value that you're going to deliver? What about the licensing? Who owns it? Right? Whether there are licensing implications that are coming from some of the components that you are using, either from hardware or from software. Now these days, you end up a lot of people calling themselves AI engineers by just wrapping some ChatGPT services. Right? Do you actually have that IP? Simply because you wrap some ChatGPT APIs, you don't own the model. Right? I'm sure like Professor Chandani will talk about some of those aspects. Right? So protecting IP. Right? Like what does it mean for you to have your intellectual property? Right? What about the licensing implication on some of the components that you're going to bring in? Right? How can you tell whether you own it? How can you tell this is my thing if somebody duplicates it? Right? So something that you have to be careful about. Then how you plan to implement, how you plan to deliver, how you plan to support, specifically when it comes to support hardware. Right? You might be doing your initial prototype, right? But you may not have the production capacity to build it in bulk. Which partners you're going to engage, which partners you're going to engage for the installation, how you're going to support it. If it is typically if it is in a hardware, it's going to go all around the place. So how you're going to do replacement, right? All that. And understanding laws of the country, some of the tax implications, some of the budget implications, right? Whether certain rules are sustainable in the long run. Now, for example, due to the fact that there are a lot of import restrictions these days, if somebody ends up developing something, right, locally, right, once the import implication goes off, your product may not be very competitive, right? And of course, like the moment that you start dealing with the customers, right, your customer is part of the delivery, right? The relationship that you are having, how your integrity, how how the ethics that you are working on plays a bigger role in keeping that customer, making that customer introduce you to more and more potential customers. Okay, moving on to the next one, about expanding. Okay. So there will be a point where like the organic cash flow that your business is bringing is no longer enough, which means you need to go for more funding, more money from others to expand your business. Okay. So a lot of material on this, but just wanted to bring this as something, a topic, because it is something very critical. So there are different options. You need to understand what it means, what you are giving out. When you are borrowing money from somebody else, you are basically giving out equity from your business. Right? So how you are going to do that? What portion of the equity that you are going to give out? Right? And there can be a point, there will be a point, or you may want to have a point where you want to exit out of the business. How you are going to do that? Right? So typically, these are deeper topics, but you need to think about it, whether you want to like do this throughout your life. Expansions like networking, how you network with other people, especially if you are in a hardware business, right? You can't do everything on your own, so you need to have partnerships with a lot of other people. If you talk to Ashane, like he would tell, like none of those things are built 100% by ourselves. I have this topic, but I don't want to talk about it because like plenty have been mentioned about this. Right? So the final thing that I want to limit myself to 25 minutes. That's why I cut it short. The final thing that I want to tell you is, in most of the cases, after a certain point in time, you would realize that the biggest competitor that you have is you. Not your team members, not other people doing the same thing. Right? It's basically what you want to do, right? And how you want to do it. So, that's pretty much it. Hope it was useful. I of course did not have any content, but I just want to have certain guidelines that I and some of my team members have discovered along the way when we had to convert ourselves from engineers into people running a business. So thank you.
Thank you, sir. Alright, now it's time to meet our last speaker for the day. For this, I cordially invite Professor Chandana Gamake. Professor Chandana is from the Department of Computer Science and Engineering of the University of Moratuwa, and he will be speaking about intellectual property and patents. Sir?
Good morning, everybody. I will talk about IPR, the intellectual property right, specifically focusing on the Internet of Things. Couple of slides I will just run past very quickly to summarize. As we have discussed today, the Internet of Things is actually an embedding of several things. This is very important when you are talking about the intellectual property rights, patents, and how to write and defend your patent rights. So essentially it is a coming together or putting together of sensors, actuators, communication technologies into physical devices. That's generally what is understood as IoT and what is used as IoT. Now, that's one part of IoT, this embedding of actual technologies into a physical device. Another part, or the second part, is the enabling of such devices to collect data. So it collects data as well as give control signals, exchange data among IoT devices, and transmit data to backend systems, and it's get done over the internet. Third one is integrating these IoT devices, the embedding of technologies, and the enabling that has been done for this device to work with data into a computer-based system that will provide a commercially meaningful it may not be commercial, but it should be economically meaningful outcome. Efficiency, accuracy, responsiveness, and most importantly in IoT case, reduction of human intervention. So these aspects are very important if we want to get into intellectual properties for IoT. Now IoT has applicability which is quite wide. So it can be in agriculture, healthcare, logistics, automobiles, business, environment. So I have just a long list. I'm not going to go through it, but just to give you an idea where that economic part comes in. So you have to tie it down into a meaningful outcome. That is where the intellectual element comes in for the patents. Now, it is very important to realize that IP, intellectual property concept, the rules and regulations, the legal system has been there for a long time. But IoT is, as we use now, as we work now, is a much more recent development. Now, one thing that sets apart IoT from, say, the internet is the fact that it is allowing us to use that technology as a revolutionary enabler, not an evolutionary enabler, it's a revolutionary enabler. So this ability to collect large amount of data in real time and respond in real time is allowing us to convert our conventional physical world into smart world. Okay, so we have smart cities, smart schools, smart factories, like that. Okay, so we have to be mindful of this aspect when we are actually working on the intellectual property right in the IoT domain. Now, before I get into the details of IoT patenting, let's get few things out of the way. First thing, as we all know, our IoT systems consist of both hardware, not both, it consists of hardware, software, networking, and maybe other technologies. Okay, so now if you take software, current rule is that source code, software in the form of source code, which is computer programs, are not protected under patent laws in our country, in India and many other countries. Okay, but we all know that software is very important. Okay, so when it comes to patenting, there are three key areas that makes anything eligible to be patented. Okay, so it must satisfy the criteria for novelty, inventive step, and industrial applicability. So it must be novel. So it is not something that is already there. And there must be an inventive step. That means it should not be something that one could do kind of obviously. The inventive step is the non-obvious step that you have thought about and for which you are making a claim. And the industrial applicability, so it must be useful. It must have, if it provides a economic benefit, that's pretty straight to say this is the industrial applicability. Sometimes it may not be a straightforward economic benefit, but in other forms also you can say it has an applicability. For example, I had this idea of putting a sensor in the chairs of my students when they are in the lecture to detect their movement. They are moving around in the chair. So to see how much of discomfort they are having. Like more motion means more discomfort. And I was thinking like, I could maybe map that into how well I am doing my lecture. Okay, so there is no direct economic impact, but I think there's no indirect economic impact. So doing that for a chair or two would not make sense. One person might be like having some issue. But if you have, now we have in our department 200 students in our intake. So 200 students, 200 chairs with this sensor and collecting data in real time and analyzing would actually be very useful. Okay, so now you can probably after 20 minutes, if the curve is way off the roof, you probably need to change track. So can improve. So that I think you can argue on the novelty of that easily, industrial applicability of that easily. Inventive step may not be so easy. So that I'm just trying to give an example. Something may look like very interesting, very useful, and quite attractive thing to do, but you have to be mindful of the inventive step. Now, while I said that software as source code cannot be, we can't put a claim on a patent, it is common to have products, devices, processors that embed the software into it as a patentable item if it satisfy the three criteria. So, for example, the example that I just gave, so you have to measure some motion, maybe pressure, things like that, and it's all data, and that data has to be now processed into a meaningful set of information that can be used. Okay, so in that case, it's all done with software. The sensors are all generic. I'll come to that also later. But that way, when it is embedded, you can patent it. So the software embedded IoT devices, we can patent. Okay, so while software cannot be patented, software embedded IoT device can be patented. So apart from the issue about software patents, there's another thing to remember about software copyright. So patents and copyrights are two different things. So even if software cannot be patented, they can be copyrighted. Okay, so not just the code itself you can copyright, and also other elements like the GUI that provides a unique look and feel, they are also copyrightable. Now, thirdly, data collected by software is also copyrightable. Okay, so now this is very important for IoT. When you are doing a business, you will be collecting a lot of data, and you have a right to that data. Okay, but you have to be mindful of the right to data, in that when you are collecting this data, if they are coming from people, you have to have consent. If they are coming from a machine, you have to have the approval of the owner of the machine. But otherwise, no, the data is also very valuable because they can be copyrighted. So now with IoT, this copywriting of data is kind of contentious, very problematic actually, because the IoT systems, we call it as a system, they have the IoT devices, the back end, so you have basically the edges of the system collecting data and controlling the systems that provide you data, but a core, a central system actually processing the data. So who owns the data is something that needs to be negotiated and decided upon. Right, so let's now get into the IPR. Very often you find that when you search databases, patent databases, that there are patents that have been granted. You think, how could they have granted a patent for that? Okay, well, on the surface it looks like an obvious thing, and now we have easy access to patent databases. One is the Google patent search, and then there's the international sites like Patent Scope. Now, so I just put this as an example. This is a patent granted by the US Patent Office to the patent is assigned to the King Faisal University in Saudi Arabia. So and usually granting of patents takes a lot of time, but this was filed in 23 June, and quite surprisingly 5 months later the application has been granted. Okay, so I can guess the reason, because they would have used a very competent and expensive lawyer or a law firm. Okay, patent application process, patent drafting process and follow-up process are all best done using a lawyer who specialize, or law firm who specialize in patent work. The first patent I got, I wrote the patent, I did the filing, and I did the follow-up, not very well. Whenever I had time, I did the follow-up. Took me 3.5 years to get it. So learning from that, the second patent, a team of us wrote, and that took 2 years. So because my main job is not patent writing and patent filing, so even with little bit of experience, I could nearly have the time. But if you are in this business, you can, you know all the things that could go wrong and proactively take action. So, so two takeaways I want to give you from here. If you have access to an expert, use the expert. Okay, but experts are very expensive, so that's why I wrote the first one myself. Second one, we had a grant, so we could pay a lawyer. So first one, self-funded. Second one, grant-funded. So so you can use either way, but no, you can read about how to write patent, but actually doing it gives you a lot of insight to what can go wrong. And this specific one is an AI-enabled IoT fog system. That means the processing happens in the edges of the network. You don't really have to take it all the way to the cloud, the centralized processing. And for looking after plants, specifically hydroponic plants, because you have to control the light, water, nutrients, things like that. So, pretty much an IoT application, well known, and you start wondering how did they get a patent for that. For that purpose, you have to read the thing. But I'm just, I took this as an example that it depends on how you draft your claims. So, in a patent, the most important thing is the claims that you make. It has several parts to it, but the most important part is the claims. So you make various claims which satisfy those three criteria: the novelty, inventive step, and the commercial applicability. And there are two categories of claims. One is one type is called the independent claims. So those claims stand on their own. So they are not tied to another claim. Second one is obviously the dependent claim, which is dependent on an independent claim. So I'll get to that in a minute, why we do it that way. So now, when you have an IoT system, they are built using different components: hardware, software, networking, systems that do the communication, back-end processing, things like that. So all of that is required to actually do the thing that the IoT system that you have designed is doing. Okay. So because of that, you can make your claims in different ways, and you must decide what is the best way for you. So in a patent, generally we have about 2 to 4 independent claims, or the main claims. Very rarely you have just one claim. Very rarely you would have more than 4 claims, 5 claims, because especially if you are using a lawyer, they charge you per claim. Okay, so $20,000 per claim. 2 claims 40,000, 5 claims 100,000. Like so you would want to actually reduce the number. Okay. Then when you decide on the type of claim, you should do it to maximize the advantage to you. I'll explain that also. Okay. So when you look at these main claims, independent claims, they could be on the device or the apparatus itself. Okay. So you have a device, you make a claim on the device. Now, if you are doing your own low-level design of these devices with certain innovations for sensing, actuation, and processing, then you can make a claim on the device itself. The next one is, and also these are not exclusive. Okay, you can make the device-based claim, a method-based claim, a computer program product, like so. It is possible to make all these types of claims. The second type is the method claims. That is for the way the device operate, or the way the device communicate with other devices, other IoT devices, or even with non-IoT devices. For example, if you take a IoT system, the IoT systems will have IoT devices talking to each other, and generally would work in the network and funnel the data. It collects into a data sync, so it goes into some centralized processing for decision making. Okay, so how you do that could be a potential candidate for a claim, depending on the novelty, inventive step, and the commercial applicability. So commercial applicability for the whole system, but no, in each independent claim should have some novelty and an inventive step. Third one is the computer program product. So here we are not making a claim on the software, on the program code, but the software implemented process that the IoT device executes. Okay, it could be the IoT device, or it could be the server systems in the backend or in the cloud. Okay, and so that one is essentially a software. Okay, but embedded. Then we can make a computing system claim on how multiple devices communicate with each other, and the particular manner in which they communicate each other. So these are different types of independent claims tied to a device or a method or a computer program product, and the computing system. Now, because you have these different types of independent claims to select from, it is also necessary to look at what is the basis on which I would select these. So these are the factors. Now, I think this very important slide was shown earlier by Sumedha. When you are doing a startup, what are the factors that influence its success? So one was the business model. Okay, so what is your business model? If you are selling IoT devices only, then it is best that you focus your claim, the independent claim, on the devices. If it is software product, then you have the option to do that. So based on the business model, it is good to look at where to focus your claim. You can, as I said, because you can have multiple claims made, you can cover you can cover all different areas, but what you want to focus on, you can decide based on your business model. Then the next factor to consider is the point of novelty. So if your strong point is on how the IoT device operate, then go with the device based. If it is on how the software operates, go with the computer's program product. Or if it is server cloud services, then go with the computer systems. So the whatever you have developed, considering its strong point, also you can select where to focus on the claims. Third one is the licensing value. Now, if you are building a IoT product and a solution, if it is applicable to a larger set of industries, if you consider it at the device level, then it is best to actually focus on that. Because suppose you have the device level IoT solution which is applicable to say 5 industries, but when you put a software layer on top of that, they become applicable only for specific industries, then make your patent applicable for the widest possible industry by making it making your claims at the device level. So, it could be that if you put the device, if you put the software product together, then it is applicable to multiple industries. But if you put it into the system level, then you need for each different industry a different solution. Then focus your claims at the device plus software product combination, because that gives you the widest coverage. Because if you want to license, not if you want to, you would want to actually license your technology, then the widest possible industry coverage will give you the widest possible customer base. And finally, when you are selecting these where to focus your claims, think about the litigation. Okay, so ultimately what happens here is, when you apply for a patent, you send the application to the patent office, they do the prior art search to check for any previous claims of similar nature, and then also do a check on the inventive step and the commercial applicability. They actually do the commercial applicability check based on what you claim. So most of the time it is easy to pass. It is the novelty and the inventive step which is a bit harder, because novelty basically would be through a prior art search. Inventive step, these patent examiners have experience in determining. Suppose you get through it and you are granted the patent, things don't stop there, because after that you have to defend, because there may be so based on your patent, you say market a product, there could be a competing product which has not licensed your patent. So you have to basically take legal action. Then they will counter it saying this particular patent is invalid because it is either well-known technology, well-known techniques, or there is or they might have a right to a different patent, and they claim that the technology out of that patent works in the same manner. So ultimately it will be decided by a judge plus the lawyers. Who talks fastest type things happen. No? So there's there is a potential for litigation. So you have to always make sure you don't go and get into a fight with your customer. So if you are going to litigate against the competitor, not the customer. So don't sue the customer saying you are using a product for which which is infringing my patent. That is a bad idea. Okay, so once you get to know as a company like that, it's very hard to get out of that reputation. Okay, impossible actually. So you will have to fight against a competitor. So check where you have the strongest ground. So if you are using commodity hardware, but if you are using custom algorithms, then your strong point is the custom algorithm. So your claims should be at that level, which which could be in the methods part. Okay. Right. So that's about the independent claims. Then we have the dependent claims. Why do we have dependent claims? Now, each independent claim, as the name suggests, stands by itself. It is not dependent on anything else. It should be able to defend itself. No, that claim covers something which is novel, something that is having an inventive step, and no, is patentable. Now, that the problem with an independent claim is it tend to be very specific, because that is how you can show it has this novelty, especially the novelty part and the inventive step. So when you have to defend your rights, something being very narrowly focused limits your arguments. So what you do is you have an independent claim as the main claim, and then within that you have what are called dependent claims. They broaden the claims on the independent one. Okay, so now you might design a IoT shoe for relay runners. Okay. I have all kind of ideas which I am not implementing. But suppose now you are supporting sports. The relay runners are now you have seen how they are like looking. They are all in very agitated mode. They are looking at their opponents where they are running, looking at the person who is supposed to give you the baton. So, so I have idea that you give the fellow a shoe which has a kind of a sensor that sense the other runner, and when the runner is getting closer, so maybe it vibrates harder. So you don't have to look at the other person. You just keep your hand, but keep looking at other runners and not drop the button, things like button like that. So now that might stand the novelty. It's not there anymore. I think I checked it actually. No one has that. Okay, but now you all know, so no longer very much novel. And it has to have some inventive step, communication, sensing, and deciding how to react. But it's very narrow. So, but it's strong. So you put that as a independent claim. So you can get the novelty part and the inventive step part fixed. Then you broaden it out of the relay races to all kind of other sports. That will allow you to cover and safeguard your claim in a time where you have to defend it, right? So anybody who like to go ahead with that, you are most welcome. Okay, and basically, if you only rely on the independent claim, very hard to fight against prior art, because there are millions of patents that will have some slight alignment to what you are claiming as the independent one. But by having these dependent claims, you can show no, this one covers all the other things also. So you had one written specifically for relay races, somebody else has done it for football, but is going to do for football, but you can say no, I have said and other sports with multiple players, like that. So that's how you broaden it. Okay, so now the requirement of relay runners and football teams are different, but this allows you to broaden the claim by writing it in that manner. Okay. Now, I hope you got this idea about independent claims and dependent claims. Now, as IoT is a combination, convergence of multiple technologies, embedded systems, sensors and actuators, as Professor Chatura and others have explained, and real-time analytics, big data, and machine learning, because most of these applications are emerging and very interesting areas that use AI techniques very in a detailed, in-depth manner. You find that it is very hard to show the inventive step in just one area: the device, the method, the computer program product, or the computer system. So it's just it's most the combination of it that gives you the inventive step. And you can write a patent claim in that setting also. Okay, and I found that when I was drafting these patents, that commercial applicability is the easiest part to deal with. Inventive step is more than novelty. Inventive step was the most difficult to deal with. Okay, different people might have different experience with that, but that's what I have found to be very challenging. Lastly, we have to be careful about a couple of pitfalls in patent drafting. Laws of nature, natural phenomena, abstract ideas are not patent eligible. So most of the time, laws of nature and natural phenomena, I think you will really recognize, okay, so this is not something that I can patent. But sometimes you tend to think that abstract ideas are patentable, but they are not patentable. Okay, so one good example is Neuralink, this Elon Musk company. So for a long time, people had this idea: you tap into the brain and do all kind of crazy stuff. Okay, so there are a lot of science fiction on these things, and movies, okay, TV series on this kind of things where you tap into the brain and do things. Is an abstract idea at that level. So the first time somebody actually who did it really was Elon Musk company, Neuralink, which they have recently shown huge progress, and they have a patent on that. Okay, so the abstract idea is not patentable. If you look at their patent, it shows the sensors, the probes, how the data is collected and what you do with it. All the details are there. So it's no longer abstract, it's very concrete. Okay. So in fact, without the kind of money Elon Musk has, you could write the patent. Patent writing doesn't require to actually build anything, but you have to give the detail. So in their patent, all the details of how the transducers are designed and connected are also given. So so you can actually, if you have an idea which is initially abstract, convert it into a patentable invention by getting into all the required details. Okay, so that is something you have to do. So so if it is an abstract idea in a claim, or the claim kind of makes it an abstract idea, you have to make sure that that you give the additional details. Okay, so I'm going to make something that plugs into the brain and repair some part. For example, you might, so the Neuralink is first going to work on damaged spinal signals, which makes people have like their arm is not working, okay? Because the connection between the brain and the arm is no longer functional. So they are going to like take from the brain the signals and external run it and get to the muscles. So you can write that. Okay, I don't think anybody have an issue writing that kind of ideas. It's pretty abstract, but then you have to give all the details and then to make it patentable. Okay, so so these are some of the very important issues to remember. Okay, so finally, why should we get into this area of IP, especially for IoT? Now, if you are thinking of a startup company, it gives immense value to the company valuation. Okay, so it shows that you are a team who are serious about this, who are trying to do things that will give you market share, that will give you a product that will be unique in the market. So those are things that investors value. And secondly, it adds economic value to the nation, to the country. So as young people who are interested in doing innovative things, I think it's very important that you keep an eye on the intellectual property domain. It is good for you to actually periodically go and run a search on these IP, intellectual property or patent databases. It's very easy to do with Google, very simple interface, and it will give you ideas also. Okay, you look at what somebody has done, and you can sometimes think of different ways of doing it, because as we all know, coming up with ideas is the most difficult thing. You come up with the idea, then after a while, what a stupid idea, like that. So, but if you go and search through a patent database, you look at 100 patents, 95 of them look like pretty stupid ideas. Okay, but if you look at who owns these patents, and some of them are owned by Samsung, Huawei, IBM, General Dynamics, these are the kind of things that when I search, I see. So they are not doing it for fun or charity, they are doing it for profit. So IP is very important. Thank you very much.
Thank you, Professor. After these informative sessions, I am sure that you may have some doubts and further questions. And I am confident that our speakers will provide you with insightful answers for these questions.
You can submit your questions via the link on the screen or by scanning the QR code. If you prefer, you can raise your hand and ask the questions, but you can always use this form.
So now the first part of the question, I mean, what is the role of deep learning in human detection in an IoT application? So human detection is the problem that we're going to solve. So basically, you may have a camera or something which captures an image, and from there you try to detect and maybe track a person, right? So deep learning is a technique that you can use. Now, processing an image and then tracking a person in that image takes a lot of computing power. So something that you need to decide is where you're going to run this this algorithm, this computing requirement. So you can run it on the edge device, or you can run it on a platform, a cloud platform or somewhere like that. Now, practically speaking, in the cloud there are services which can offer this particular algorithm for you as a service, right? So one option is that you can design the system such that it captures the image and then transfer that image into whatever the cloud service that you're going to use, and it will run and it will give you certain parameters back to your system, your device, so that it can act on those things. And to detect that person, also there are, whether it runs on your device or on the cloud, there are different methods of doing it. I mean, deep learning is one method of doing that solution. And there are other algorithms as well. So what you need to look at is that you should not, when you try to solve a problem, I mean, you are trying to solve the problem of detecting and tracking a person, right? So you need to find what is the best method of doing that. So deep learning is one method. I don't think you should use deep learning, because nowadays there are a lot of talk about that, and people are talking about deep learning and various AI-based methods. Now those trends might change with time, right? So what you need to look at is, this is my problem, there are different solutions that can happen, and each solution will have certain limitations, restrictions, economic concerns, marketing concerns, sustainability concerns, all those things. You need to evaluate all those things and select, for my particular application, what is the best way of doing it.
Thank you, sir. And the next question, is it possible that if I am working in an industry after my graduation, I am planning to continue my IT startup as a founder? Is there any legal issue that will rise? I'm doing a startup with several university IT students, and I will join in an electrical engineering industry after graduation. However, I want to continue my startup as well. So I believe the question is regarding balancing work and doing a startup.
Okay, it's like this now. If you are doing a startup, there's a recent talk from Elon Musk on this. It's very, it requires a lot of focus. So if you forget about all the ethicalities, all the legal aspects and everything, right? One thing is, you really need to give it a thought whether you want to, what you want to focus on. It can't be that during your daytime you are working on a company, and on your night time you are focusing on your business. It's practical to a certain level, but definitely beyond a certain point, it will come to a point where you need to pick up what you want to do. So there are quite a few who are doing a day job to earn some money to use it as a fuel for doing something else. People do that, but then again, after a certain point in time, they make a switch. They decide, okay, now it's time for me to either switch 100% into developing my own business, or else this is not going to be practical for me, and I'm going to go into the full-time employment, right? And at the same time, there are social things that you have to think about, right? Now, typically at your age, right, now, your life is not only about running a business. There are so many other things, like you have certain responsibilities, you have social responsibilities, you have like responsibilities to your family, your parents, right? Now, if you want to take care of all of those things, there are certain ages where you can do certain things in a lot more focused way. Okay? That is why we have probably Professor Chandra and Professor Chandra will tell. That's why we have lot of people going for PhDs in their like certain ages. Like ages. Now, it's not that like people who are in their old ages cannot go in and get a PhD. Right? It's just that their environment is such that it prevents them from, like, focusing on something so deeply. It's not that they don't want to do that. It's just like everything else prevents from doing that. Right? So that's one thing. And the second thing is, now, if you want to run your own startup, right? If you want to do your business, if you end up going and meeting investors, right, they would look at how focused you are to do this. Because at the end of the day, if somebody is willing to invest their money on that, right, from a venture capitalist point of view, from an angel investor's point of view, what they are looking for is a return. Right? Now, if you keep it in a bank, let's say like the bank is giving you 50%, 15% interest rate, they would obviously look for like 25%, 30%. Okay? Now, just think of it from an investor's perspective, like whether they will be investing their money on somebody who's not even 100% focused on the idea. So that side is there, right? And and then again, like it's a bit of a long-term thing, right? Now, if you don't have a proper idea of where you want to drive this, right, after a certain point in time, you might decide, okay, like I don't want to do this, right? Now, those type of things. Now, these days, now supporting startups itself is a business. You have to realize that. And there are a lot of companies, even in Sri Lanka, it's happening. Like a lot of companies who would offer you space, who would offer you very nice lit environment for you to like go there and like invite you into talks like these, to tell you about the journey, all that. Who's going to put you under the limelight for a different purpose. Right? But at the end of the day, if you are running a business, if you are doing a startup, it's you and the team who have to like make sure that things are happening in a way so that you can keep the lights on. Right? Now, it's a combination of things. So it's something that you have to don't go for the trend of just need to evaluate critically whether this is something that I want to do. Would I be having the energy to keep on doing this for a long time, right? And at the same time, would I be having the rest of the environment sorted at least to a certain level for you to keep on doing that for some time at least.
Thank you, sir. All right. Just a reminder that you can always raise your hand and we will give you a mic to ask your question. Right. So there's this question. It says, I have an idea, but I lack the knowledge in product development. What can I do?
So, if you have an idea, right? So there is no formula. It's just like there is no formula for success, no. So there is no formula for a startup. So the whole idea that we call as startup is when you have an idea and you see potential in that idea. First of all, you should see the potential and you convince other people of that potential and make it into a product, service, and go to market. So if you have an idea, you have to convince others. It's very hard to convince somebody else about ideas. So the way we normally do is we go from an idea to what we call a minimum viable product. At least it has the outline of a product, the main capabilities that you expect in a product, and may not be anywhere near the final product, but it is a minimum viable product. So my suggestion would be to go from an idea to a minimum viable product, and then that would take you, doing that would educate you on what are the missing parts for you. For example, you might be very good in computer science, software engineering, but you may have some deficiencies in areas in electronics design, and then you would want to have a partner who could fill that gap. So that partner could be a company in China which will build the thing to you, or better if it is somebody with whom you can throw ideas around and improve it. So that's what I would suggest if you have an idea. So, but I think big part of the problem, or the big part of big distance of the startup journey is already covered, because you have an idea that you think is worthwhile. So I think that's a very good thing. Very good thing. If you already think, I have an idea and I think it is good, that's excellent. Because even if you don't think it is good, then convincing somebody else it is good is not going to be practical.
Something that I would like to add now. Most of us, like here, we are like engineers by training and by profession, etc. But I have had the luxury of working with few accountants, lawyers who are having software related product ideas. Now, in their case, now they don't now in our case, if we come up with an idea, for example, what Professor Chandra said about the sensor, right? Now we would understand how to break that into all the way into the electronics level to get it figured out. But the difference is, whenever those guys come in and discuss their idea, one of the clearest things that I understood was they had a very good understanding of what they want to do. They don't know how it can be done, how it should be done, but they had a very clear understanding of what they want to do and how they are going to make money out of it, and how they are going to make that something valuable for others so that they would pay for that. And for that, they were willing to invest some money to get that MVP implemented. So having the idea, I mean, like, you don't have to be an engineer to get an idea implemented. There are enough accelerators. There are companies who are actually into the business of getting somebody else. I can't remember that name for those type of companies. Basically, what that company would do is they would help you to implement an idea. So it's if you know the idea, what you need to realize is, what all of us need to realize is, there are things that we're good at, then there are things that we know. Right? For us to do something, it doesn't mean that you have to know everything. There are people who will be willing to contribute in other areas. That's why where you need to collaborate with others and get some others to join your team who would believe what you want to do.
All right. I believe this next question goes out to Mr. Ashin. The question is there a standard method of testing IoT products?
Right. Let me ask a little rhetorical counter question. Is there a very specific way to test a fridge? Right. Now, if you want to test a fridge, right, someone would say, let's test the temperature. Right? Let's see how it will perform if you leave it in the sun and turn it on. Can it cool the products inside? Right. So we are testing the temperature. Then we are testing the current that is used, right, the efficiency of the fridge. So as a whole, if we get in the same context, if we get an IoT product, right, there is no specific way to test the IoT product, but we can test the technologies that is involved, right? So in a generic IoT product, there is going to be a microcontroller. So there is a way to specifically test the microcontroller. Right? So as I discussed, we can test the firmware. And then in any IoT product, there is a communication method. If it's wired or wireless. So we can test the communication protocol from end to end. And then there is the hardware component. We can test the hardware component. But as a whole, there is no such way to specifically a generic way to test IoT products, but we can test the factors that is in the IoT product, right? So depending on what your product is, if you are making, if I can get the same product, the same example as Professor Chandra said, the shoes, right? So once you build the shoes, then for that specific shoes, there must be some wireless component, there must be a sensor component, and then we can see, as Professor, in the same example, if the two runners are running closer, how close or how far that they have to be in order for that to work properly. So what are our ends, right? As I said, for the whole test. So we can apply those concepts, but as a whole, as in generic, there is no specific way for any product. Any embedded IoT electronics product, there's no specific methods, but we can use specific parts of testing to each of our hardware concepts.
All right. So the next question is about money. The question is, how can we find a better cash flow for our startup as students? Funds or freelancing or etc.
It's like this now. First of all, whatever that you are going to do, right? In general, if you want to earn a cash flow, you need to provide something valuable where somebody is willing to pay money for that. Right? So that's like, forget about the IoT side of things, right? First of all, you need to solve a problem so that somebody is willing to pay money for that. Right? Now, for a startup, now if you want to, whenever you want to implement an idea, right, you need to have a rough idea of what the budget that this would mean to get me to the MVP level. Right? Now, that is why, on my slide, I had angel investors, venture capitalists. There are different categories of startup investing. Okay? So, and then there's another method called bootstrapping. Bootstrapping is, so basically you just run your business through the money that you are generating. Right? Now, one thing is you can start small. Right? There are certain things that are practical in that way, where you can start small and keep on doing that, getting into bigger projects. Right? So once you realize you are going to get a bigger cash flow, you can increase the number of members in your team. Maybe initially you are only doing this from yourself, but after a while you get 1, 2, 3 people who are going to support the same objective. Right? And at the same time, while you are doing that, now I had a slide on that understanding the laws of the country. Now within Sri Lanka, labor laws are very strong. Right? So you can't just hire a person and fire, right, under certain terms. Right? So that's where like hiring somebody as an independent contractor would come into the picture. There are like there are more opportunity, more rule for you to stop getting services from somebody else if it shows you that you are not going to get the same cash flow, so you can't keep on burning your cash at the same rate by having a higher number of people. Same thing with certain other services that you may want to get. Right? Say for example, for you to run some of your hardware, if it requires a certain cloud backend, right? If those cloud backends are like costing you money, right? Now basically you need to understand, can I actually pay this money for the pay this cost for the services that I am providing? Is it actually worthwhile? You can't be like earning 1,000 and like burning 2,000 for a long run. Yes, you may be able to do that for a shorter run, given that by doing that for 1 year, you will be able to show a bigger value so that somebody else will come in and invest in your business, or a bigger customer would come in and like give you bigger revenue. But understanding how the cash flow is going to come in is something very crucial if you are running a business. Right? Otherwise, the moment that you run out of money, right, all the other problems of like even if it is only you, right, you may not be able to like run out of money and survive for like 1 year. Maybe you can do that for 1, 2, 3, 5, 6 months. Okay? So if you want to run it as a business, right, you should be able to have that, do that planning ahead of time, assume certain things, and have certain predicts, and also have some hope that certain things will work out. Because sometimes things don't work out the way that you want.
So let me add a little bit more to that as well. So in the embedded systems design life cycle, like product development life cycle, as I discussed, as I showed, so we start with the proof of concept, the initial concept and the electronics verification stage, the design verification. I told you the design should look good, and finally it should be manufacturable, right? So until this manufacturable process, I think so Medha would also agree, until this manufacturable process, there won't be money coming in, right? So until that, you will be running on investments from the concept to final manufacture and sales point, right? Which is the mass manufacturing or manufacturing stage. There won't be money coming in. And in embedded systems, we call that the valley of death, because that's when there will be, from the moment that you have the concept, there will be money burnt to do the first PCB, the circuit design, to get it fabricated, to get the hardware, right? To test it, to get all these certifications I mentioned, right? To FCC certificate, ISO certificate, even SLS certificate. It'll be burning money until sales. From after the sales point, you start generating revenue, and whoever the investors, or if you're the investor, you will be getting some money out of it. So it's really tough, and as Sumedha said, getting your cash flow sorted is very, very important.
Maybe I also can add something to that. I mean, actually 2 points I want to highlight. One is that when you plan for product, I mean, end of the day you are designing something and you are trying to sell it and earn a revenue and a profit out of that, right? So when you look at the cost of your product, there are 2 components. One is what we call the NRE cost, non-recurring engineering cost. The second one is called the unit cost. Now, unit cost is the material, workmanship, parts, etc. that goes into production of a single unit of your whatever you are saying. Let's say you are doing a watch, and that material cost will be the cost of the strap, the plastic, the metal parts, the electronic components, battery, etc. that goes into this one. So if you are going to if the material cost for 1 unit is, let's say, $10, if you are going to make 100, it will be 10 into 100, $1,000. It has a linear relationship with the number of units that you are going to market and sell. The NRE cost is all the costs that Sumedha and Ashen talked about, right from the concept until you get the product running on. Now that is a bulk of the cost, kind of a bulk cost, which will not depend on how many units you are going to sell. Even if you sell one unit, one single item, that NRI cost will be there. So you need to recover that cost by the number of units that you sell. And that's where you need to plan. When you can sell it, when the optimum market space is there, when you can get the best revenue out of that, because once you start something, if your product is very much, accepted by the market, there will be competitors coming in. Some of these competitors will be very big players, right? So you have a small window to make yourself stable in the market. So you have to plan to get the best opportunity of that window. That's one thing. A second thing which I have seen, I was working for in the Sri Lanka Inventors Commission some times back, and then one thing that we see is that you should not, you should never try to market the value of your product. To place your value of your product simply based because that you can make it cheaper due to a non-sustainable situation. Because very often we see people, inventors coming and say, okay, I made this particular product. Right? There are compatible products in the market, but I can make it cheap. Why he can make it cheap? The prototype he has made using discarded parts from various other devices. Right? But if you are going to use real new parts for that, it will be more expensive, especially when you do it in a small scale. So one thing you need to realize is that, you can't make 100,000 units of like that using discard part. That's not practically possible, right? So especially when you go for an investor, you need to think about that. Those are the things that the investors will ask. What is the cost? What will be the incremental cost? How long it will take to start generate revenue? So you need to think about those things with the idea that you are having. Right? Getting the idea to a viable product is one aspect. Getting it a viable and a profitable product in the market is a different aspect. Right? Sometimes they may not travel in parallel lines as well. So that's something you need to think about right from the beginning. Unless you have a lot of money with your parents or something like that, you can spend and you can afford to lose a couple of million rupees. Thank you.
Yeah, and it is very important to remember that costing is not a simple summing up of the expenses that went for the components. Now, suppose you are creating an IoT device, so obviously you have to put together the cost of these components, and then you have the cost of assembly for the device. But apart, like that, no similar cost that go into and testing and packaging. But also you have to factor in that if you are going to be a success in the market, that success will be determined by your customers. So it is essential that you give a warranty. Anything from, if you can give a 1 year warranty, that would be great, but at least 6 months. So if you are going to give 1 year warranty, you have to factor in that maybe 20% of the devices you put in the hands of your customers will fail for all kind of reasons. But especially in the initial years, whatever the reason, you have to honor a warranty and give a replacement. So the cost, ultimately you have to add that also. So the unit cost is not the cost of the 100 units you are selling, but the additional 20 that you have to keep in inventory and support the warranty. As Professor Chatru said, you have to account for all of these things and see how much it costs. Otherwise, these claims of I can do things cheaper, therefore I can get the market share, really has no basis.
Okay, thank you, sir. Thank you, sirs. All right, I believe we have time for 2 questions from the audience. Do we have any? Any raise of hands? All right. Before we wind up, I would like to ask one more question. It's like a cherry on the top for this Q&A session. The question is, what do you think? Is it Internet of Things or things connected to Internet? A very subjective question, perhaps?
I think both are same. It depends on what you call a thing, right? I mean, in future there will be people who might do things because artificial body parts, and then people also might be something in between, right? So it depends on how you look at that. So I think there are few key aspects that defines what is IoT. I mean, it has a communication. As now, if you take a standalone device which is not connected to anything, sometimes we call it an embedded device, but we don't call it an IoT device because it doesn't have a communication perspective. Right? But IoT, one key integrated, the word term IoT is that it has a communication perspective. One device can talk to another device in a formal or a structured or unstructured way. They can share information. So whether it's things connected to network or network connecting everything, it depends on what your focus is. I think both are same. Thank you. And also, just one small thing, if you have interest about this IP rights and things that we did, there's a very nice movie called Flash of a Genius, based on a true story. It's available in Netflix. Right? It talks about the inventor who invented this intermittent wiper in cars. Right? I mean, the cars has intermittent wiper, right? Not continuous one which runs every 5 seconds or something like variable time. And how big companies try to steal his idea and then try to not to pay him loyalty, and how he ultimately, end of the day, how he went litigation and he got his due rights. This very nice movie came in 2008, but still now available in Netflix. If you have time, and access, try to see that movie. That will give you a lot of insight into that, something that really happens in the world.
Also, Million Dollar Code is another movie that's on Google Earth. Same story. With regard to what Professor Chattra said, even though coming from an IoT background, I don't see there's a hype around the term IoT. That hype is now pretty much it is gone into a different level. So there's something called hype circle. So if you guys are interested in understanding what is trending these days, just take a look at technology hype circles, and you would know what are the keywords that are hyping, and what are the keywords that are going into the maturity level, what are the keywords that are going off, etc. Right? Now, what IoT actually does is, it's the same set of applications, right? But with the sensors and actuators, you are getting a more realistic view of what is happening at the ground level. Okay? So, to the applications that were there 15 years ago, 20 years ago, right? With the sensors or actuators, you are able to get a lot more realistic understanding of the ground level. Okay? So, it's basically another level to change the standard IT applications that we were already aware of. So it's just a new technology layer. Right? So now what it means is, whenever we are working on new technology, we are working on enhancing the user experience. I know I'm telling this from a completely different perspective, but it's that user experience for which people will be paying for. Right? If you are, the moment that you elevate the user experience, it is for that you have to put a price, you can put a price tag. Right? Now with the sensors, now when I look at these seats, if you guys have gone into a 5D or a 6D cinema, right, you would see that the seat is vibrating, the same seat. Right? Seat is vibrating, then there are sprinklers or air nozzles coming here, where it's going to give you a different sound, or they are coming in. Right? So it's a different experience. The same chair modified with bunch of sensors so that you're going to give a new experience for which somebody is willing to pay an extra amount of money to come in and be on that cinema. So if you look at it from that perspective, right, forget about the term IoT. Right? Now the same thing. Now if you try to apply the same thing for machine learning or artificial intelligence, it's just an extension of the same applications using different technology domains to elevate the experience that you are giving to the user. Right? So then the VR is there. Right? I don't know whether you guys have seen now there are applications where you can can compare to you going in and mouse hovering over certain menu items. Now there are applications where you can wear a VR headset, focus on that menu item, and it will take you there. Just imagine opening up a Google document using that way. It's the same thing that you were doing using a mouse click. Now there's a different experience for you to do the same thing. So it's all about value creation. Engineering is a very important part of it because that is what helps you to implement it. Right? But if you look at it from that perspective, it becomes very easy for you to make certain decisions about what to do versus what not to do, how to do versus how not to do, what technologies use. For example, like Professor Chatura said, mentioned about the AI part of it. Like it's about providing a solution. Technology comes later on. You have to pick and choose.
Yeah, so adding to what Sumedha said, right? From electronics perspective, back in the day, we had televisions, and then we had the whole, CRT, the box. Eventually, it became flat. There were LCDs. Then now we can connect it to the internet. Right? So back in the day, we had just analog cars. Now we have ECUs. And now Tesla has the whole environment where it can, if the car has a problem, it will order the parts from itself. Right? Similarly with air conditioners, similarly with the refrigerators, Samsung smart refrigerators, smart air conditioners, smart this, smart that. Right? So I'll be a little philosophical, because everything is now becoming IoT, not IoT per se, but connected. Yeah, you can call it connected to the internet, right? IoT and connected to the internet is the question. So yes, things are becoming connected to the internet. As Sumedha said, the experience is elevated, right? But are we going overboard and are we secure? Two questions, which I'll leave rhetorical. Right? So we are making everything connected to the internet. Yes, that is good. Are we going too far, and are we secure? Because if it's analog, and if it's just analog, if it's just a closed system, that's it, it's closed. Right? But the moment it is connected to the internet, the moment your home door lock is connected to the internet, the moment your home surveillance is connected to the internet, the moment your smart home system is connected to the internet, the moment your car is connected to the internet, there is it may be an unreachable breaking point, but there is always a possibility to break it. Break open that security. Right? It may be unreachable for now. Right? It may be unreachable with today's technology or the technology that is around us. Right? But there can be a possibility that it is reachable by someone, or someone might find a loophole. Right? So from analog electronics, what we had, say, 10 years ago, right? So when I was doing in my first year, right, back in 2014, 15, first year, right? My first year we had a module called design project where I had to do a product with a team, and I did a Bluetooth bulb holder, right, at that point. So that was a novelty idea back in the day, like controlling a bulb with Bluetooth and then using internet just to turn on and off a bulb. Right? It was such a wow factor. Now we have that module to be sold. I think you can find it online on AliExpress or something for about less than 1,000 rupees, I think. Similar like add-on. So what we designed was we retrofitted an already available bulb holder with just 2 Wi-Fi modules, and it was like a small unit where we pasted 2 cups together, and then we mounted it to an existing B22 holder, the normal pin type holder, sorry, less technical pin type holder, and then you can plug in your whatever the bulb you have at home and you can control it from internet. That was a wow factor back in the day. Now that is there, it's already existent and it's already cheaply, readily available technology. So now everything else has become money. So question is, are we actually secure and how secure are we? So I'll leave that rhetorical leaving it to you.
Thank you, sirs. And I believe that marks the end of the Q&A session. Although we didn't get any questions from the audience, we would kindly request if you could give feedback on this workshop, if that's possible. Do we have any feedback from the audience? Okay, I think we are on to something. We have someone who is going to speak, I believe. Okay. Yes.
The session is really good. We gain a lot of knowledge and experience from the industry level and the seniors from our university as well. So it's pretty good to be here and gain some knowledge about it. Thank you.
Thank you for that feedback. We appreciate that a lot.
So, as we draw closer to the end of the day's proceedings, it is now time to appreciate our guest speakers for being here with us today.
I would like to invite the co-chair of the SLIoT Challenge, Sanjula Gatsara, to hand out the token to our first speaker of the day.
I would like to call upon Professor Chathura on stage to receive the token of appreciation.
Thank you, Professor Chathura. Next, I invite Dr. Kotila, the academic advisor of the SLIoT Challenge, on stage to hand over the next token of appreciation.
I cordially invite our second speaker of the day, Mr. Ashen Fernando, on stage to receive the token of appreciation. Thank you. Then I invite Mr. Ayoma Wickramaratchi, Deputy General Manager of Product Development and Management of SLT Mobitel, to hand out the next token of appreciation.
Mr. Sumedha Rubasinghe, please come on stage to receive your token of appreciation.
Thank you. Now we call upon the co-chair of the SLIoT Challenge, Nimet Menuka, on stage.
I cordially invite Professor Chandana Gamage on stage to receive the token.
Thank you. As we come close to the end of today's workshop, we wish to extend our heartfelt gratitude to everyone who made this event a success. To mark the conclusion, I would like to invite the co-chair of the SLIoT Challenge 2023, Sanjala Gatsara, on stage to deliver the vote of thanks.
Thank you, Sadali. I stand before you with a heart full of gratitude as we conclude the SLIoT Challenge 2023 workshop for the University and Open categories. This event has been an incredible journey made possible through the support and dedication of remarkable individuals and organizations. First and foremost, I extend my heartfelt thanks to our academic advisor, Dr. Kutla Gunasekara. Your guidance has been instrumental in shaping this event. A heartful and special acknowledgement is extended to our esteemed speakers for today, Professor Chandana Gamage, Professor Chaturadi Silla, Mr. Subendra Rupasinghe, and Mr. Ashen Fernando, whose insightful presentations and expertise have significantly enriched our workshop experience. We deeply appreciate their time, knowledge, and commitment to sharing valuable insights with our participants. Also, I extend my gratitude to the dedicated academic staff of the Department of Computer Science and Engineering for their continuous support and contributions to the success of this event. A sincere thank you to SLT Mobitel and IESL for the generous support significantly contributed to the success of the event. A special mention to the SLT Mobitel once again for the assistance in ensuring the smooth execution of the event by providing the venue at the SLT Mobitel Head Office Auditorium. To the organizing committee, your tireless efforts and meticulous planning have made this event a seamless reality. Thank you for your dedication and hard work. Lastly, but certainly not least, a big thank you to all the participants in the University and Open categories. Your enthusiasm and thirst for knowledge has made this event truly special. In closing, let's carry the inspiration and knowledge gained here forward. Together, we can create an environment that fosters innovation and collaboration. Thank you all for being part of SLIoT Challenge 2023 workshop. I wish you all for the best to advance to the finals. Thank you.
Thank you, Sanjala. With that, we have arrived at the conclusion of the workshop. Once again, a massive thank you to each and every one of you for taking part in today's event, and we eagerly wait to see your innovations during the semi-finals.
Wish you all the very best. Goodbye and good.